Despite some constraints, I think that designers in this era hold more power at their fingertips than ever before. I worry that too often we get caught up in cynicism and lose sight of the fact that we're living through one of the most innovative, impactful, creative, and abundantly resourced eras that there's ever been to practice. Never before has there been such an extensive and productive yet accessible collection of design tools that have the potential to facilitate projects of previously unimaginable complexity and breadth, and I hope that this isn't taken for granted. The architects of the generation that came before us were shackled to the rectilinear. Their designs could explore exquisite material palettes. They could choreograph striking use of balance and proportions or exaggerated scale. It could manifest with rigid symmetry or fragile asymmetry, architecture that achieves harmony with nature, with an acute emphasis on clean vertical and horizontal lines. They could accomplish this delicate and highly considered performance of light, architecture that glowed and softly illuminated, or architecture that boldly framed dramatic and rigid shapes. It could be remarkably functional, sometimes to the point of an intimidating cold sterility. They could aggregate out sprawling arrays of mass-produced repeatable elements. All of this could develop an exceedingly evocative character. This era culminated in some truly wonderful architectural moments. But nevertheless, it was compromised. It was compromised because of the lack of or prohibitive cost of tools and resources that shackled the extent one could creatively explore. It was nearly impossible to build anything that couldn't be framed in plans, sections, and elevations. It was an architecture defined by 2 dimensions and an inflexible production process. So what about now? The relentless innovation of those that have come before us has privileged us with unprecedented accessibility to the most incredibly powerful, potentially impactful, and blazingly efficient tools for design that have ever existed. What used to take teams of draftspeople weeks to document can now be repeatedly generated by an individual with 1 click. Structures that could barely be calculated by teams of ambitious engineers can now be automated and optimized instantly, potentially rationalizing and documenting tens of thousands of structural members at once. The suite of prototyping tools fabricate more rapidly and with levels of precision orders of magnitude higher than ever before. 3D printers can be left unattended to independently produce intricate physical mock-ups of digital designs. In a few hours, laser cutters autonomously carve up reams of meticulously sliced card that would have previously consumed laborious weeks and left fingers mangled by tiny blades. These tools can facilitate more ambitious physical models than ever previously imaginable. We're now able to explore and refine material palettes and simulate precise evocative lighting conditions without needing to physically model or prototype anything, iterating and learning from outcomes orders of magnitude more efficient than before. Costly resource-intensive mediums that in prior generations were reserved for a privileged few can now be practiced affordably and repeatedly. And these are certainly not stuck in the digital realm. These tools have highly optimized and integrated fabrication procedures. We are living in one of the most exciting times to be an architect, not just from the production standpoint, but because of its expressive, accomplished physical outcomes. Contemporary designers can grapple with greater complexity, sophistication, and depth than ever envisaged before. And we're seeing this renaissance transition across disciplines, from architecture to fashion to landscape design, furniture, industrial design, web applications, VFX, video games. These tools are relevant and have potential to be applied across every realm of design, allowing practitioners more opportunity to transition in their professions. So then, why does 98% of the built environment feel so mundane and so ill-considered and so unambitious? And why am I introducing a software course like this? It's because these tools are challenging, and I hope some of the community's most accomplished and impactful work can inspire you to continue to apply yourself, even if you're finding these concepts that I'm introducing you to challenging or daunting. As you go through this, the most important thing is that you acknowledge that you're embarking on something that's ambitious and accept that there may be arduous moments, but getting through them will dramatically elevate what you're capable of modeling, documenting, and visualizing. So what is Rhino? Rhino is probably one of the most powerful geometric modeling tools for architecture. It's far more powerful than SketchUp in terms of what it can model, and it's also leagues above other geometric modeling softwares, whether it be Blender, 3ds Max, Maya, or Cinema 4D for architectural modeling because of its integration with Grasshopper and its library of community-coded plugins that can parametrically model, rationalize, and fabricate building elements en masse. Rhino also connects to a suite of rendering software to create professional visualizations, which I'll intend to introduce to you soon. It exports visualizations to Photoshop and Linework to Illustrator, as well as building information software like ArchiCAD and Revit to create building documentation for non-standard buildings. If you want to produce non-standard building design, then Rhino is pretty much a must-have in the architecture industry. So who is this tutorial for, and how can you use it? Well, at this stage, I've had the privilege of teaching hundreds of architectural students at university, and there's a pretty clear consensus that almost everyone wants to be able to learn a software and start to apply it on their own as quickly as possible. So this will give you all the information you need in 2.5 hours while being as clear as I can possibly be. If you already have experience in Rhino, I still guarantee that you can learn something from this, and I've added timestamps below to help you get the most of this tutorial. If you're a complete beginner, then I have good news for you too. This tutorial was designed particularly with you in mind, so there's no assumed knowledge, and if you're completely new to 3D modeling, this tutorial will explain everything from the ground up. Make sure that you follow along on your own computer with Rhino open to practice every command yourself, or else you just won't absorb the knowledge properly. I've designed it so at the end you'll have a range of outcomes that you can put into a folio to demonstrate that you can model, render, and document proficiently inside of Rhino, which I hope might be useful for university or job applications. The next question is, what does this cover? Over the next 2.5 hours, I'll show you how to model with every geometry type in Rhino, from points to curves to surfaces, meshes, sub-Ds, blocks, text, annotation, and dots. We'll cover creating both diagrammatic as well as photoreal visualizations by correctly mapping materials and creating effective lighting setups. I'll show you how to create a range of strategies to create documentation from isometric line work to plans to sections. I'll help you optimize your modeling for file size. I'll show you how to create models that are optimized for fabrication so you can have files you can 3D print, and along the way I'll also try to make a few mistakes in this so that you can develop your skill set to problem solve in Rhino, because in my experience watching tutorials never goes smoothly or exactly like the instructor says it will, so it'll be really useful to have the skill set to solve problems. I'll also note that this tutorial series is updated for Rhino version 8, but I've ensured that you can follow along even if you're using a Rhino version as early as Rhino 5. And the information that you learn here will be relevant for 99% of Rhino 9 when it likely launches in a couple of years to come. The tutorial is done in a Windows system, but if you're using a Mac, everything's still relevant. Whenever I say use the Control key, just use the Command key, and if I say to use the Alt key, just use the Option key. Finally, I'll try to get to as many questions in the comments as I can, but it would be great if everyone supports each other in the comments section because we're all trying to learn this together. I really hope that this can be beneficial to you, and I encourage you to try to enjoy the process because that's what we're here to do. I might just quickly also mention that it's been a huge amount of work to put these tutorials together, not just the Rhino resource, but there's heaps of tutorials to come. So let me know if it was worthwhile to you in the comments below so I can gauge whether it would benefit the community to continue to make more. Subscribe if you want to continue to learn from resources like this. Hit the like button if you think that it would be useful resources for others to learn from so that the YouTube algorithm picks it up. And consider following Legacy Design Studio on Instagram if you want to learn from short form content. For those of you that want to support more resources like this for the community, then maybe consider anything from shouting a coffee to a software license on Patreon. That would be greatly appreciated as I work late into the night to give you more resources. There's a link to Patreon on the Legacy Design Studio website. Lastly, when I was learning the workflows that I've put into practice, it was super demotivating and inefficient to have to cover the same content multiple times over because there was no single resource that covered everything from start to finish. It was also really challenging even finding resources that were relevant because obviously you can't learn about something if you don't even know that it exists. So I've been thinking about putting together an extensive chronologically formatted course that would take people from complete beginners to advanced level workflows in everything, covering digital modeling, graphic design, diagramming, documentation, presentations, visualizations, all in one succinct module, one after the other, and all in one place. I'm a bit apprehensive because it would be a huge and pretty exhaustive undertaking and a pretty big commitment, because if I was going to do it, I'd want to do it right, so it would need to be monetized somehow to make it feasible, but that would also support more free content that could become available for the community. Let me know in the comments if you think that this would be worthwhile to put together for you, so I can gauge whether it would be feasible and sustainable. If you'd be super interested, maybe consider signing up to be notified if I was to make it available in the link below, because I might make a trial period to some members of the community to get feedback on it. With all of that covered, let's get into learning Rhino. So to get started, you'll need to download a copy of the Rhino software. To do this, just Google Rhino McNeil. McNeil are the people that develop the software, and go to their downloads page. Thankfully, you can download a free 90-day trial, after which you'll need to purchase the software outright. You can either do this through a commercial or a student account. Once the software is downloaded, just run it like you'd run any other installer. Unlike every other piece of software which has turned into a subscription model recently, McNeil still sell their software outright, and this means that even though there's a higher upfront cost, the long-term cost of ownership will tend to be a bit lower. The only thing to be mindful of is that McNeil tend to release updates every 2 years or so with new features, so we're up to Rhino 8 at the moment, and this has new documentation and fabrication tools, as well as a whole bunch of other stuff. But you don't need to upgrade if you don't want to, so I know a lot of people that would still be using Rhino 5 or Rhino 6, just because they don't really need those new features. The other thing to consider is that when you do upgrade, you get a pretty substantial discount compared to the original purchase price, so it's only really a fraction of the original price to buy the software if you wanted to upgrade. Once you've downloaded and installed Rhino, it's time to launch it for the first time. You'll be greeted by a startup interface where you can choose a template. Make sure that you specify large objects millimeters as the units that you're working in, as these are the standard architectural units of measurement. For our friends in the United States and Liberia, you can also follow this tutorial in imperial units. Just specify the template to be in inches and feet. You'll also notice that you can open your recent projects up the top as well. If you miss this menu because it's easy to not click on, you can go to Properties and then adjust the units down here. Once you've started Rhino, this is the viewport that you'll be greeted by. The first thing that I'm going to do is model a piece of geometry. To do this, I'm going to navigate to the Solid menu up the top. This top menu contains pretty much all of the commands in Rhino, which it groups by function and geometry type. For example, when we create curves later, we'll find the relevant commands in the Curves menu, and when we create sub-Ds, we'll find the relevant commands in the Sub-D menu. Exploring through these menus is a really effective way of learning what each of the commands are in Rhino. You'll notice there are two windows that change when you go from Curve menu to Solid menu. Both this top menu as well as the window to the left-hand side of the screen changes what functions are shown. The first piece of geometry that we're going to create will be a sphere, and to do this we're going to click the sphere icon on the left-hand side. When you click this command, you'll notice that it registers in the command bar up the top. This bar will give you prompts specifying operations. In this case, it's specifying the center of the sphere. To do this, we're going to use what's referred to as the perspective viewport. Please follow me and click exactly where I click. I'm going to go to the window labeled Perspective and click where this red and green line meet in the center of the model. You'll then notice that the command bar asks us to specify a radius of the sphere. Let's draw it out and then click to finalize the geometry. You'll now notice that there are 4 spheres on the screen. And although the perspective viewport's shaded solid, these other viewports are represented by Linework. These windows represent the top view, otherwise known as the plan view in the architectural profession, as well as the front and side view, otherwise known as elevations. To give you a better idea of this, if I had a chair, this is how it would be represented in each of these views. You're able to maximize a particular viewport by double-clicking on the viewport name, like I'm doing here for the perspective viewport. I'm also able to change the viewport properties by clicking on the drop-down icon. By default, the perspective viewport should be shaded. Wireframe will give you this look. Rendered will give you a textured look with shadows. Ghosted will give you a particularly transparent look. Arctic will give you a clay-like viewport. And monochrome will give you line work around the edges and change the background color. Feel free to explore the rest of these. There are a few commands you need to know to navigate around your model, and to do this you really need to own a mouse because navigating with a trackpad is extremely inefficient. In my opinion, you don't need something fancy like an ergonomic mouse or anything that advertises a high response time. These tend to be marketing gimmicks to sell you something more expensive than you really need. This is my mouse, for example. It was only $15 and I've used it basically every day for 7 years and just thrown it in and out of my bag and not really taken very good care of it, but it's sort of been fine even for millions and millions of clicks. Having said that, the best tool for you is the one that you enjoy the most and that gets you excited to use it, so opt for whatever you want. But if you are interested in any of the gear that I've researched and tested and found to be the best for these types of design workflows, then check out the gear link in the Legacy Design website. I'll link it below in the description. If we go back to the standard toolbar, we'll find our navigation tools. The one you'll use the most is Rotate View, which is represented by 2 circles with an arrow around them. When you click this, you can see that you can orbit around by clicking the left mouse button and dragging. Thankfully, you technically never need to use this command icon because there's a shortcut to do this. This is to hold down your right mouse button and drag across the view. Similarly to rotate view, the hand icon is a command called pan. By clicking it, you'll be able to pan around without rotating the view. However, the shortcut to do this at any time is to hold down the right mouse button and drag, but this time whilst holding down the shift key at the same time. So with that sorted, let's start modeling. There are 7 main types of geometry in Rhino that you can model with. These are points, curves, surfaces, polysurfaces, sub-Ds, meshes, and blocks. I'll introduce you to each of these in the modeling exercise. The first thing that we're going to do is model a base for our pavilion. To do this, we're going to make sure that we make the base in the absolute center of the model. And to achieve this, we're going to make a point by clicking this point tool over here. You'll notice I won't be able to place it exactly in the center right now. So to do this, we need to turn on our snap settings. The first one that I'll introduce to you is this one down here called Grid Snap. Grid Snap will allow us to snap onto the grid lines we can see in our viewport. You'll notice down the bottom left-hand side of the viewport that there is an X, Y, and Z axis. You'll notice as I move the points around, it changes the X, Y, and Z position. If we put it at the center of our model, you'll see it will say 0, 0, 0. We can then use this point for the center of our circle. Click the circle command and then specify the point we just made as the center of that circle. You can then type in 115 and hit enter, and this will make a circle with a radius of 115 units. In this case, my units are millimeters. There are 2 main other ways of modeling curves. The first one I'm going to introduce is the polyline command, which creates straight lines in straight sections, which you finalize by hitting the enter key or by connecting it back to the curve starting point. If you can't snap to the first point you started, then you'll need to turn on your OSnap settings. Your OSnap settings can be adjusted by these buttons down the bottom. Grid Snap, as we said earlier, will snap what you're doing to the grid. See how I'm now able to draw out this curve in a way that it only snaps to the grid lines rather than snapping exactly where my cursor is? The next tool is called OSnap. OSnap will let you snap onto things that you've already created. For example, see here how I can't connect the curve I'm now trying to make to the curve that I've already created. To do this, I'll need to turn on the OSnap function down the bottom here, and then go to these settings over to the left. If I specify end, then I'll be able to snap to the ends of the curve. If I tell it to snap near, it'll let me snap anywhere on the curve, or any other geometry for that matter. Mid will let me snap to the middle points. And int will let me snap anywhere that the geometry intersects each other. If you turn on Smart Track, you'll notice that it'll help you extend a curve parallel or perpendicular to what you're drawing and the geometry that it intersects. It's also worth noting that if you hover over commands in Rhino, it'll pop up a helpful dialog box explaining what the command does. I mentioned there was another kind of curve that you'll routinely model with, and this is the interpolated curve, which is a bendy type of curve. Now that you know how to model curves, there are a few main commands that we can use to modify them. These can all be found in the curves menu up the top. I'll list out the modifiers that people generally use 95% of the time, but I encourage you to hover over each of these and get an explanation and understanding of all of them. Start by typing in each of these commands and then follow the prompts in the command bar. Firstly, the move command will allow you to move anything from one position to another. Rotate will allow you to rotate that curve from a center point like this. If you've finished a curve but decide that you want to continue, you can select the curve and type in continue curve, and this will allow you to add additional control points. If you decide that you want to edit the positions of the control points on a curve, you can type in points on, and this will allow you to select and then move the individual points that the curve runs through. The split command allows you to use a point or intersecting curves to split another curve. For example, if I draw a curve over this circle and then type in split, it'll ask me what I want to split, and I can specify the circle, then press enter. Then it asks you for what you want to cut, and I can select the curve I just drew and hit enter. You can see that this will split the circle in half. Let's hit Ctrl Z to undo the operation so that the circle is just one curve again, and deselect everything. This time, instead of using the split command, we'll type in trim. Now it asks for a cutting object, and I'll specify the straight line and hit enter. Now it asks for objects to trim, and if I click one side of the circle, it will trim it. If you hit enter, it'll end that operation, and then after that, let's hit Ctrl Z to undo this. Another command is offset curve. Once we select a curve and type this in, we can specify the distance that we want to offset the curve by, being a number like 50, and it'll offset it like this. If you have a polyline or any other line made of multiple straight section curves, you can use this explode tool to unjoin them. You'll see after using the explode command on this line, each of the segments becomes its own curve. If you want to join these curves back together, you can use the join command. Then select each of these segments and hit enter on your keyboard, and it'll become a single curve once again. If you have a curve with straight sections, you can use the curve fillet to soften the edges. Just type in fillet and then specify the radius of the fillet. A large number like 80 will give you a large fillet. To see this, we just need to specify the two curves that you want to fillet between. So I can select curve 1 and then select curve 2, and you'll see the fillet. If we undo this by hitting Ctrl Z and then fillet again, but then this time with a smaller value, like 10, it will give you a smaller fillet. You can use the scale command to scale it larger or smaller. If you only want to scale it in one direction, then you can use the scale 1D command, and it'll scale it in that single direction. Tween curves will allow me to quickly create a set of curves between each other. Just draw out two curves like this, and then type tween curves. By default, it'll only have made one middle curve, so we can type in 10 and hit enter to create more curves. Curve Boolean is a really useful operation if we have intersecting curves like this and want to create an outline between certain regions, such as on a floor plan. We just type in curve Boolean and then select the regions that we want to create the outline around. Let's clean this up by deleting everything that we've done so far except for that first circle. Let's just leave that for the time being. Massive congrats everyone, because if you followed through this far, you now know the commands that Rhino modelers will typically use to model 99% of curves. And not only that, but these commands are going to be very similar to the commands to alter other geometry types like surfaces, polysurfaces, sub-Ds, and meshes, which I'm going to introduce to you next. Before we do, I want to introduce you to a really efficient modeling shortcut to move, rotate, and scale geometry to help you model as quickly and efficiently as possible. To do this, we're going to use the Gumball Tool. To turn on the Gumball Tool, we just press the Gumball button down the bottom of the toolbar, next to the buttons that we ran through earlier, like Grid Snap, OSnap, and Smart Track. You'll see that this will pop up a super helpful blue, green, and red tool over whatever geometry that you've selected. You can use these arrows to move whatever you've got selected in either the X, Y, or Z directions, and if you move it while holding down the Alt key or Option key on Mac, it will create a duplicate of the geometry. I'm then going to undo all of this, and then go to our standard tool palette, and then click the Box tool. I'm going to use the box to demonstrate some more Gumball principles. You'll see that there are also semicircles. These can be used to swivel the geometry around a particular plane. There are also these dotted lines, and they allow you to scale in a particular direction. If you hold down the Shift key, it will scale it uniformly in every direction. You can also click on these tools to modify them in a precise way. For example, if I wanted to move something up 10 millimeters exactly, I would hit the blue arrow once and then type in 10 and then hit enter. I can also hit the semicircle and insert 180 degrees and it will rotate exactly 180 degrees around. I can also click the dotted scale tool and scale it by an exact factor of 0.5. Depending on the view, there'll also be these tabs to move it on a particular plane like this. You can adjust a few properties in the Gumball tool. For example, if I draw out a single segment curve like this, you can see that the Gumball tool isn't aligned to the curve. It's aligned to the standard Rhino axis known as a C-plane. So it can be useful to go to this menu and change the alignment from C-plane to Align to Object. Now when we select the curve, you'll see that it aligns to the curve itself, which can be super useful. The next thing that we're going to do is turn our base curve into a surface. To do this, we're going to use the most basic surface command called planar surface. Planar surface allows you to turn a flat, closed curve into a surface. Just type in planar surface and then select the curves we drew earlier and hit enter. There are a few other ways to create a surface which I think would be really useful to quickly cover. So here are 4 other commands that you would tend to use 99% of the times to create surfaces from curves. If we take our closed interpolated curve from here and move some of the points upwards, so like this, then select the curve and try to use the planar surface command again, you'll see that this will fail and it'll tell you that no faces were made and the curve has to be closed and planar. To make a surface from most closed curves, we can use the patch tool, type in patch, hit enter, and select your curve. You'll then be prompted with some settings, and these are fine for the moment, so just hit enter. You'll see that this then delivers quite a complex surface with lots of control points. You'll then see that this delivers quite a complex surface with lots of control points rather than a simple surface like the planar surface command. So you want to opt for planar surface if you can, because the simpler your geometry is, the easier it is to edit, and it also keeps your saved file sizes as small as possible. Another option is to extrude a surface. To do this, type in the extrude command and hit enter. Then select a curve and you'll be able to extrude it upwards. Notice that in the command bar, there are options for the direction and length of the extrusion if you wanted to use them. I also want to mention that you're actually able to extrude curves into surfaces more efficiently using the Gumball tool. To do this, start to drag the curve out in a direction and then hold down the control button on your keyboard. The loft command will allow you to join together a range of curves. For example, if we draw out curves like this, and then move some of them upwards and downwards, then type loft, select the curves and hit enter, that will create a surface that sweeps through each of those curves. You can change the style of loft, switching between normal or straight sections or tight. Another useful option is to hit closed, which will close the loft back into itself. If you want to be more specific about the direction that the loft takes, you can use the sweep command. If we draw a new curve connecting these curves that we originally used to create our loft, and then type in the command sweep, we'll be prompted to select a rail. So select the curve that we just drew. Then it asks for a sweep shape. So we'll select the curves that we lofted earlier and we'll hit enter. You'll notice that the sweep follows the curve that we drew. There's also a command called sweep to, where you can draw 2 rails to be even more precise. As I said earlier, the great thing is that all of these tools that you've learned to modify curves can also be used to modify surfaces. So, for example, you can trim a surface. If we want to trim our sweep surface, we can trim it with the curve that we used to create it like this. Or we could extrude that curve upwards and then move it downwards like this, and use this surface to trim the swept surface as well. If we undo that, then in the same way, we can split that surface as well. See how if I use that split command and then split it with this curve and hit enter, it will split it into two separate geometries like this. Then let's just delete that swept surface and all of these curves, because I'm going to introduce you to another tool called offset. Let's use the offset surface command on this surface. And we just need to specify a distance. So here I'm going to use 10, and you'll see that it'll create a solid offset like this because the solid option was turned on up in the command bar. We can redo it and turn that solid option off as well. You can then tween between these surfaces using this tween surface command, just as I taught you to do it with curves earlier. So if I select my two surfaces, and then I can also change the number of tween surfaces between each of the two. I might make it 10 and then hit enter. If you want, you can turn a surface back into curves using the duplicate surface command like this. See how now a curve has been generated around the perimeter of that surface? Now that you're familiar with those commands, we can begin to build up our model. Let's delete everything except for the 115mm radius circle that we made earlier for the base of our model. At the moment, this surface is flat. To make this three-dimensional, we're able to extrude the surface into a poly surface. Let's try that by using the extrude surface command and specifying extruding it up by 15mm. Make sure that the solid option is selected, as well as the delete input option, and then hit enter. You'll then see that we have our next type of geometry called a poly surface. A poly surface is just a collection of multiple surfaces joined together. So if we use the explode command like you learned how to do with curves earlier, it'll break it up into its constituent parts. Let's undo that and use the fillet command, just like we learned to do with curves earlier, to fillet the edges of this poly surface. To do this, type fillet edge into the command bar and specify a radius of 7.5. This is half of the 15mm distance we extruded the base earlier. We can then select the top and bottom edge and hit enter, and you'll see that it fillets the edges of the poly surface in the same way that it filleted the edges of our curves earlier. Now that we have our base modeled, we're going to start modeling the pavilion design itself. The first thing I want you to do is create another sphere. I want you to put it at the center of the model, but unfortunately the base is getting in the way. This is where the layer menu comes in really handy. If you look over to the right-hand side of the interface, you'll see another set of menus. Go to the top menu icon, which is the one that looks sort of like a multi-level orange, white, and blue cake, and this is our layers menu. For anyone that's modeled in SketchUp or edited in Photoshop before, this is the same sort of concept. Rhino automatically starts its new files with 6 different layers. We have our default layer up the top, and then we have these 5 different layers below it. If we wanted to make a new layer, we could click the plus icon up here. We can use this plus icon up the top to create new layers. You'll notice that our default layer has a tick on it. This means that it's the active layer. So any geometry that we create will automatically be in this layer. If we want to change the active layer, then go to that layer and click in the same row to activate that tick. I might leave layer 3 active. Now anything that you create will be in layer 3 because it's the active layer. We can test this by making a sphere and then selecting it. And you'll notice that down the bottom, there's a menu that indicates which layer the selection is on. This is actually a pop-up menu, so if you click on it, you can get all of the same menu options as the layers menu on the side. This can be useful to gain extra screen space to model in by hiding the side view, but still retaining some layer options. A better way to check which layer your geometry on is by changing the layer color so that each layer is visually different. If I click this colored box, you'll see that I can change the color. This will change how the geometry is represented depending on which layer it's on. You will notice that it does this for every viewport mode, like wireframe. ghosted and shaded. However, on rendered mode, it doesn't change color. For those of you that haven't heard this term before, rendering is a process of creating presentation quality imagery from our digital model. So instead of having diagrammatic use of colors, like in the shaded viewport, we'll be using the rendered viewport to assist us to produce images with realistic material palettes, atmospherics, and sophisticated and intentional uses of light. For now, I'm just going to give you a quick example of how we can apply these through the layers menu. This is just so that you understand the elements of the layers menu, so don't worry about focusing on creating and applying new materials, because I'll teach this in far greater detail in the render section. You can see if I click under the material palette, I can create a new custom material, like this, and then I can change some of the material qualities, like the color, if I click here and it'll bring up this window. Then I can change the reflectivity, the transparency, the glossiness, and so on. We'll go through this in far more detail later on once we finish modeling our pavilion. If we go back to our shaded view, we'll be able to change this other option in the layers menu, which is the line type. We'll also go through this later in greater detail, where I'll show you how to use these tools to create some really exceptional drawings and imagery. The other extremely useful functions for modeling in this menu are the light bulb icons, which will make certain layers invisible. You'll notice that you can make all of these layers invisible except for the active layer. If we make a sublayer by dragging the existing layer into another one, or by creating a new layer up the top, you'll notice that all of the layers will be affected by whether the sublayer is visible. The final icon we'll cover is this lock icon. This allows us to lock the geometry on a layer so that we can't select or edit it. If you right click on a layer, various options will pop up. The important options are the options to select any geometry in this layer. You can then change the selected objects to another layer. You can also duplicate a layer and its objects. If you want to delete a layer, you can use this big X icon up here, and you can use these up and down arrows to organize the positioning of each of the layers that you've created. Let's rename layer 1 to base and put our base on it. I'm then going to lock that base layer, then delete. I might make the layer color light blue, then delete all the other layers for now. And now we're going to start modeling our pavilion. To create the overall shape of the pavilion, I'm going to use the top of a sphere. So let's create a sphere. I'm going to make sure that it's right in the center of our model by typing in the coordinates exactly. The center coordinates can be written as 0, 0, 0. This is similar to how you probably would have mapped points in a Cartesian plane in high school maths class with 2 dimensions. Here it's 3-dimensional, so we have 3 values. This is how we tell Rhino that we want to create a point where the X coordinate is 0, the Y coordinate is 0, and the Z coordinate is 0. Let's hit enter, and I can then make a sphere that is roughly as large as the base itself. I'm then going to use the Gumball Tool to move the sphere down so that there's roughly this much distance between the outer perimeter of the base and the circle. We're then going to use 3 more spheres, which are going to cut out the openings of our pavilion. We'll do this in the top view, so let's double click on this perspective label, and then go to our top view, which is here, and double click on it to maximize it. Following this, let's make sure that this view is in shaded mode. Then I'm going to use the zoom extents command to zoom to the geometry that we've created this far. Now let's create another sphere, but this time it's only going to be 2/3 of the size of the last one. Then I'm going to use the Gumball tool by holding the Alt key to duplicate 2 more. We then need to arrange them so that they're evenly spaced out over the original ball. You can do this by holding the plane symbol on the Gumball tool to drag it around the same plane, which means that it's not changing the height position. Try to get it so that the distance between here and here on each of the sides is roughly the same. Once we do that, we can go back to our perspective view. If you don't want to minimize and maximize all the time, you can use these labels down here. And this will let us switch between each of these viewports that we have active. So if I press perspective, then it'll take us back to our perspective viewport. This is what it looks like while we orbit around whilst we've already created. To create openings in our pavilion, we're going to go to our solid tools menu, and up the top, we'll use what's referred to as our Boolean tools. There are 4 main Boolean tools, and their functions are sort of summarized by their icons. Firstly, the union tool lets us join closed surfaces together like this. You'll notice that after the Boolean union operation, when I select one of these spheres, they'll all be joined as one surface. If I use the explode command and pull them apart, you'll see that it's turned them into one seamless solid. Let's hit Ctrl Z to undo that Boolean union so that they're all individual spheres again. Let's skip to the third tool up here, which is Boolean intersection. If we click that, it will prompt us to select the first set of surfaces. So let's select the 3 spheres and hit enter. Then it'll ask us to select the second set of surfaces. So let's select the large sphere and hit enter. Now you'll see that all that remains are the parts of each of those geometries that intersect. Let's hit Ctrl Z to undo this and move on to the last tool, which I'm going to introduce, which is the tool that we're actually going to use, modeling. This is the second Boolean operation from the left, and this is called Boolean difference. When we press this tool, it'll prompt us for a surface to subtract from. So let's go ahead and select our large sphere and hit enter. Then it'll prompt us for the surfaces to subtract with. So let's select the 3 smaller spheres and hit enter. This is a good start to the pavilion, but as you can see, it's not hollow. This is the type of geometry that I described earlier as a polysurface because it's made up of multiple individual surfaces joined together. So to make it hollow, we can select it and use the explode command. You'll now see each of these can be selected as individual surfaces. I'm going to select the 3 internal parts and then delete them. I also want to remove part of the sphere that's protruding underneath the base. And to do this, I'm going to use the trim command. Now when we use the trim command, it'll ask me for cutting objects. Let's select the base and hit enter. It's then going to ask us for objects that we want to trim. So let's select the sphere, making sure to select it underneath the base and hit enter. However, you'll notice that when you select this sphere now, that it's trimmed to the bottom of the base. We really want it to trim to the top of the base, so let's redo it. If you hold the Control and Shift keys down together at the same time, this will allow you to select the individual components of a polysurface or a mesh. So here you can see I'm able to select out the outer surface like this, or even the curve that makes up the outer surface. But what I'm really interested in here is the base. This is what I want to use to trim the sphere. So let's use the trim command again and then cut the base of the sphere off. And now you can see it's trimmed to the top of that surface. The next step is to create the staircase. To do this, we're going to make use of a tool called Contour. So let's start by typing in Contour and pressing enter. First, this asks us what objects we'd like to use to contour. So let's select our sphere. Following this, it asks us to select a base point to contour from. Let's select the base of our pavilion. Next, it asks us a direction. So let's go and minimize our perspective viewport and go to the right plane. We want the direction we're contouring in to be directly upwards. So let's hold down the Shift key and right click. The final thing it asks for is a distance. So let's type in 2.5 and hit enter. You'll then see it create contours in increments of 2.5 millimeters. Let's make a new layer for those curves and call it stair curve. And I might make the color bright red. You may have deselected your curves and it'll be a pain to reselect all of them. There are 2 shortcuts I can teach you to speed up the selection process. The first one is that if you go over here to your OSnap settings, you'll see that there's another menu called Selection Filters. At the moment, every type of geometry is selected, as you can see from all of these ticks. However, you can uncheck every box by holding the Control key and then just select a single type of geometry. We just want to select curves. The great thing about using the Control key is that it's only temporary, so after making a selection, it goes back to the selection settings you had earlier. If you want to change these settings manually by ticking and unticking the boxes without holding Control, it'll stay like that permanently. The other option is the Selection Command shortcut. These are useful if you want to select all of a particular type of geometry in a scene. For example, if you want to select all of the curves in the scene, you would type in Cell Curve. If you want to select all of the surfaces, it would be Cell Surf. This is the same for every type of geometry, so meshes, blocks, dots, annotations, and so on. A really useful version of this tool is Select Last, and this will select whatever geometry you've operated on last. In my case, it's the curves. And then you can type invert to invert that selection. There's actually a huge array of selection tools that even very experienced Rhino modelers typically don't know about, which you can explore by going to the selection toolbar here up the top. You can find tools like Lasso, where you can create a lasso selection. You just click the tool and then draw a shape and it'll select anything inside that shape. Or brush select up here, where you can use this brush to create a selection. If ever you accidentally create duplicates, you can use the cell dupe command and select all of the duplicates. And if you're struggling with file size, you can use the command cell small and specify a size to delete anything that's smaller than that. This can be really useful to be used with city models or the incredibly powerful parametric tool called Grasshopper. I'm going to use the command cell curves again and then change their layer to my stair curves layer. I might also select this sphere and make a layer called sphere geometry. And add it to that layer. I'm then going to change the color to light pink to differentiate it. And then let's lock the base layer and the sphere geometry layer so that we can more easily select our curves. Let's also delete this red curve here because it's not really relevant to our modeling anymore. I want you to select all of the curves on one individual side, making sure not to select the curve that goes all the way around to the other side of the staircase. Let's orbit around so that we can see them from the side, and we're going to hold down the Alt key to duplicate them, then click on the blue arrow. We'll then be able to put in a value. Let's put 2.5 because that's the amount that we contoured it by, and hit enter. And now we have all of the curves we need to make our staircase. Let's select them again, like this. And then type loft and hit enter. Rhino's loft command is excellent at finding paths through curves, and you'll see that we have ourselves a wavy staircase now. Let's go to the settings and change from normal to straight sections loft. This will make the stairs vertical and horizontal rather than wavy. We're only going to loft one staircase at a time, so once we've done one staircase, let's repeat it for the other two. Now we're going to make a flat top for the pavilion. To do this, we're going to edit the sphere geometry. However, I want to keep a copy of the original, which we'll use later. So let's go to its layer, then right click on duplicate layer and objects. Let's hide the original layer and rename the new one Pavilion Roof. I'm also going to change the color to a more vibrant color of pink to differentiate it. While we're at it, let's hide the red stair curves layer and make a new layer called Stairs Lofted for our lofted stairs. I'm then going to select the stairs and select our Stairs Lofted layer, right click and select change objects to layer. I might make this red as well. The next thing we're going to do is flatten off the roof. To do this, let's unlock the Pavilion roof layer and select this piece of geometry. We're going to use those lofted stairs to split the roof. So let's type in split and then select our stairs. With that done, let's hit enter. You'll see that it'll split the geometry like this. So let's hide our stairs and we can select this roof section that we've created and hit invert to invert our selection. We're then going to delete all of these excess surfaces. We can then turn back on our lofted stairs layer. You'll then notice that the surface is bendy, but we actually want a flat floor for our roof. To flatten this surface, we can use a really useful command called setPoint. This allows us to project geometry in a particular axis and flatten it. For example, if I set the point to the Z axis and pressed OK, then I can click on the top of the stair and it'll make it flat. Now that this is flat, you can see not all of the stairs finish in the same position. What I can do is hold the Control and Shift key at the same time, and then select each of these parts of the stairs surface individually and delete them. Now let's make a light well in the center of our roof by turning on our stair curves layer and selecting the center circle. I think I'm also going to make this bigger by making the dotted scale tool while holding down the Shift key. This will keep the circle symmetrical. We're going to use this circle to trim our sphere. But to do that, we need them to intersect, and at the moment the curve is hovering above the roof level. We could use the setPoint command again, but I think this is a good opportunity to introduce another command called project. Project lets us project the curves at a surface, and compared to setPoint, this can be used to project these curves to a wavy surface as well. But in this case, we're going to use it for a singular plane. So let's type project and hit enter. Firstly, it will ask you to select the curves and points. So let's select your curves and then press enter. Then it asks us what we want to project onto. So let's select this roof surface. We can also specify a direction up the top in the command bar. This can be either using a Z direction, which means that it will project directly downwards, or we could project the curves based on our line of sight. Let's just project them directly downwards for the time being. Now we have a curve on that surface so we can use to trim that roof. I might hide the red stair curves layer to make it easier to work. And now let's trim the roof to make that light well. See how trim doesn't seem to work at the moment? Unfortunately, there can sometimes be issues with operations, as is the case in all modeling software. Because of this, it's important to know how to troubleshoot. In this case, I suspect there's an issue with the surface itself, so what we can do is rebuild the surface. We can do this by selecting the surface and typing in dupe border to create an outline of the border. We can then delete the original surface and then go to the border curve that we just generated. After selecting this, type in planar surface and it'll generate a new rebuilt planar surface. We can now retry that trim operation. And see, it works fine this time. So let's now change the surface back to our original pavilion roof layer. We now have the rough outline of our pavilion shape. The next step is to make it three-dimensional. To do this, let's make a new layer called thickened surface. Then let's select the roof and sphere geometry shape. And then I'll right-click on the new layer and copy these objects to that layer. This will give us duplicates to work with so we can hide the sphere geometry and the pavilion roof layer. I might make this layer a bright blue. I'm going to select both the surfaces here and then use the extrude surface command to thicken them. However, in this case, I only want to extrude down the flat surfaces, not the vertical ones, or else it will produce some weird geometry that we might not be able to join later. So firstly, we need to unjoin all the surfaces here using the explode command. Then let's go to our top view and quickly select all of the flat surfaces individually. Then we can go back to our perspective view and use that invert selection tool again to delete all of the vertical surfaces. Now we can type in the extrude command and it will prompt us to select our surfaces. Let's make sure that we extrude them in a downwards direction by moving our cursor below the surface, and we might specify a distance of 5 units. Once they're three-dimensional, we can use the Boolean union command again to join them together. And with that done, let's change what we've made back to our new blue thickened surface layer. Now we have our solid 3D pavilion shape. We're going to both smooth the surface of the geometry as well as create the railing to stop people falling off the staircase. We could easily do this by extruding or offsetting the edges and then using the fillet tool, but I think this is a good opportunity to introduce another modeling tool in Rhino called subds. So what are subds? Well, so far we've covered curves and surfaces, which are rigid and precise in the way that they're modeled. However, what if we wanted to create a more organic and freeform geometry? Well, this is where subds come in, because modeling subds is more like a sculpting experience compared to what we've covered so far. And similar to sculpting clay, where anyone can just pick up a piece of clay and start to morph it, subds are also relatively straightforward to get started with only a limited number of tools associated with them, but it requires the understanding of some formal principles and then a bit of practice to develop a high level of skill with it. I'm actually working on a subd course to demonstrate these principles, so make sure that you subscribe and hit the notification button for that. It'll also probably be released for free earlier on the Legacy Design Studio website, just to get some feedback before I actually publish it to YouTube, so maybe check out that and see if there are any other unpublished videos that may be there already. Before we utilize subd modeling in our pavilion, let me run you through the basic modeling tools. Again, these are the tools that most modelers use 90% of the time. Subds can be created in two different ways. Firstly, if we go to the subd menu up the top, you'll see that there are all of these tools for primitive modeling. So if I wanted to quickly make a basic subd surface, I could do this, or a subd sphere, or a subd cone, a subd torus, or a bunch of other shapes. I can quickly do that here. The other option to create a subd is by converting a surface or a mesh into a subd. So if I were to create a loft shape through 3 curves like this, then we can use the command toSubd and make sure that you specify to delete the input surface so that we don't have to double up those surfaces, and hit enter. You'll see that this is converted from a loft surface to a subd. Now that you know how to make a subd, let's see how we can model and modify them. Let's start by making a simple subd plane. The fastest way of modeling subds is with a system that you're already familiar with, and that's by using the Gumball Tool. You'll see that if I select this subd, ensuring that the Gumball Tool is turned on down the bottom of the window here, that the Gumball Tool will let me move it around, rotate it, and scale it. The most useful tool though is the shortcut that I taught you that lets you extrude using the Gumball Tool. To do this, let's select our subd, then begin to drag it upwards with the blue arrow. Now, before unclicking the mouse button, press and hold the Control key. Then we can let go of the mouse button. Once extruding this, you'll see that there's a range of faces. To sculpt the subd, we need to select them individually. Similar to what we did earlier when we trimmed the bottom of our sphere, we can select faces on the subd by holding Control and Shift when we make the selection. So let's hold Control and Shift and then select one of the faces up the top. We can then move this up individually, like so. And while we're moving it up, we can press and hold the Control key to extrude it rather than just move it. Just by doing this, we can build up extremely sophisticated sculptural models quite quickly and produce the same design language as buildings famously created by Zaha Hadid architects or mad architects, with free-flowing dynamic lines and curves reminiscent of natural forms. There are two main principles that you need to know when building up these sculptural forms. These both refer to topology. In modeling, topology refers to the arrangement and the organization of edges. Good topology is consistent in its shape and sizing. See here, for example, the edges on the left are all different shapes and sizes. Some converge with others, and there's no clear pattern. The middle sphere is better, but although the distribution of edges is clean, it leads to some faces being much larger than others. The final sphere has all quad faces, and this means that the faces all have 4 sides each, instead of having quads and triangles. Also, the faces are all equally sized. They're also cleanly distributed. Both are examples of good topology. You may need a more specific style depending on your application, but an understanding of that only really comes with practice. The second principle that you need to recognize is that when there's less detail or resolution, e.g. there are fewer edges and faces in a model, it's more editable. So you should start by editing with the least amount of detail as possible. Think of this as how someone would model a face out of clay. First, they would produce the overall shape, and then they would add the intricate details later, like facial structure, eyebrows, or pores. This is because in order to make large changes, you'd need to change many faces, and there isn't really a quick way of selecting lots of them easily. There are a few other selection tools you need to know. Firstly, if you double click on any edge, it will select every edge in that loop. If you select one edge, then go to an edge further along in that loop and double click it, then it'll select all of the edges on that side of your first selection. If you select one edge and then another, followed by double clicking on an edge between them in that loop, it'll select all of the edges between those two. This also works for faces, so if I select one face and then another in that loop, and then double click, you'll see it will select them in the same way that we were able to select the edges. You can do this in any direction that you want, and this will help you to quickly build up a selection of those edges. You can use these selection tools to then move or delete edges if you wanted to clean up your topology. I'll take you through this in more detail soon. When you have a lot of elements that you want to move, you may want to use a soft selection tool to move many faces at once. If you select an edge on this sub-D and then go to the sub-D toolbar and select this soft selection tool, it'll prompt you to create a certain sized sphere. This sphere will determine how many objects will be affected when you move something. If, for example, you were to make a large sphere and then go to move this edge, you'll notice that the other edges will move simultaneously with it and create this bulbous shape. If you want to toggle soft selection off, you can click the icon, ensuring that you don't have anything selected, and then go to the command bar and turn off this enabled, and hit enter. Now let's go back to that quick sculpture that we made earlier and explore the next topic, which is visibility settings of these sub-Ds. See how at the moment by default our sculpture has soft edges? This is because we're in the smooth subdivision preview. However, there's another preview which we can apply by hitting the tab key, so let's do that now. By hitting tab, we toggle between the smooth display and the control polygon display. These displays represent the underlying structure of the sub-D surface, and they can be a really useful way to edit without the soft edges getting in the way. This will be particularly useful when you develop much more complex sub-Ds in the future. Now that you know that you can use the Gumball tool to generate sub-D models, and that you can hit the tab key to change between smooth sub-D and polygon view, let's quickly practice these skills to build up a basic sculptural form. Remember, to select individual faces, you need to press the Control and Shift key together at the same time as you select the face. And then to extrude the face with the Gumball tool, you need to start dragging the face and then hold the Control key before you release the mouse button. Now that you know the fundamentals of what sub-Ds are and how to generate some of the basic blobby forms, I'm going to introduce you to a few tools that you'll probably use for 95% of your sub-D modeling. Firstly, to help you create good topology so that you can edit sub-Ds more effectively, I'm going to show you how to insert additional edges. If you select edges that are adjacent to where you want to create more edges and detail, then type in the command insert edge, you'll see that it allows you to add an edge in so that that topology is more evenly proportioned. You will notice that the edge isn't exactly where I have my cursor. If you hit Tab to go into the Polygon Sub-D preview that I showed you earlier, you'll see why this is. It's because you're putting the edge in the position of the underlying structure, whereas if we hit Tab again, you'll see this will relax the view and these edges to a different position. This is why Tab Preview is important to model topology. If you want to add more detail across the whole model, you're able to use the command Subdivide, which will split every face like this. Just keep in mind that you want to keep the sub-D as low resolution and editable as possible for as long as you can, before you add in extra detail. Now that we have that edge, you can use a tool called Slide to move it across the face of the topology, backwards and forwards like this. As I showed you earlier, when you select an edge, you can delete these edges by hitting the Delete key. This is a really important tool for creating good topology. You can also select faces and delete them if you want, which will create an opening. This modeling technique is a way of achieving the sort of design language that you see in some of the incredible pavilions by The Very Many, a design studio run by Mark Finez. If you've deleted a face and want it back, you can use the Fill tool. You'll notice that if I use this tool for a hole with 4 edges, it's pretty straightforward. However, I can use this to fill holes with more than 4 edges as well. If I delete a few more of these faces, particularly faces around a bend, and then select them, and then fill, you can see that it connects very poorly, both in terms of the shape I'd ideally like, as well as the topology. This is where the Bridge tool comes in handy. Bridge, like the name infers, lets you take unconnected edges or faces like these, and then create a bridge, which is a connecting piece between the two. You'll find that bridging also works for faces that you want to connect, and is a very effective way of taking multiple sub-Ds and connecting them into one. You can see in this menu that pops up that we're able to specify how many segments should connect between them. This can be really handy if you want to add curvature to the connections later. Stitch is another way of connecting disconnected edges together. Unlike bridging, where you can create new faces between the edges, stitching will combine the faces into one. So if I delete those faces again, and then type stitch, it will prompt me for the first set of curves. Let's select these curves here and then hit enter. Let's then select the second set of curves, which are these ones here, and hit enter again. And you'll see that it combines these into one. When it does this, I can choose how close to put the stitch from either one of the first set of edges, or the second set of edges. If you want to smooth out the topology of the edges, the Bevel tool can be very handy. Type in Bevel, and then select an edge and see how it creates additional edges either side of them, and this will smooth off the shape. You'll notice that if I hit Tab, the lines become a lot more legible. Another way of adding edges is by insetting them. If you type in inset and then select a face and then set a distance to inset it by, it'll create additional edges inside that face. This can be really useful if you wanted to create a bumpy geometry by taking the inset face and extruding it out like this. Some of the shapes that you might want to model in the future might be symmetrical. For example, if you're creating a face, obviously it's reflected evenly across both sides. A useful tool to model with reflected geometry is the Reflect tool. If I type Reflect and hit Enter, and then specify this geometry, then it'll ask me for a plane to reflect through. I might just put that here, and you'll notice that it's now reflected it through both sides. What's really neat about this though, is that it's not just reflecting the existing sub-D faces. If I go to change something, such as this on one side, it'll also continue to be reflected while you model in the future. Okay, let's undo that reflect command and we'll move on to the last tool. This is a tool called Crease, and you'll probably use it more than any other except for the Gumball tool whilst you're sub-D modeling. Crease allows you to change the edges from these blobby curved ones that you see here to sleek, sharp edges. To apply a crease to an edge, just select an edge that you want to crease, and then type crease into the command bar and hit enter. Since Rhino 8 came out, you've also been able to change the weighting of these creases. For example, if I don't want a really harsh edge like this, then I can use the command subd crease, select the edges that I want, and then put in a percentage crease value. 10% will make very smooth creases like this. 50% will start to get a bit sharper. And 90% will be much sharper still. But if you want that fully creased shape, then just use the crease command, not the subdecrease tool. If you want to remove these creases, just select the edges that you want to remove the creases from, type in the command remove crease, then hit enter, and you'll be back to the default blobby edge. Now that you have an overview of how all these subds work, we're going to use a subd tool to create the railing around the stairs. We have two options to do this. The first option is that we model it from scratch. However, when we're digital modeling, we should always try to be as efficient as possible. So I want to introduce you to a strategy where we'll use what we've already modeled to create our subd, and then we can morph it to suit our needs. But to do that, I need to teach you about meshes first. Meshes are the final geometry type that there is to learn about in Rhino, and I'm going to show you a quick demonstration of what they are. We've already covered NURBS geometry, but let me refresh and reinforce your understanding. NURBS geometry is a type of geometry that's mathematically defined, similar to how you might define a circle or a line in a high school maths equation. This means that the surface of this sphere exists in an infinite number of places, so no matter how far I zoom into the edge, it will always follow the curvature of the circle. Subd geometry is different to this. Subd geometry is made up of vertices, which make up edges and faces. We can see this if we turn the points on command on, which I introduced to you earlier in curves modeling. When I hit tab, it changes from smooth display to polygon display. This smoothing effect is also mathematically defined like NURBS geometry, and this means that so long as we're in the smooth display mode, no matter how far we zoom in, it will always have a smooth surface. Mesh geometry is similar to subd geometry in this way, however, there's no smoothing effect. When we zoom in, we can see that it's made up of planar or flat faces. The benefit of this type of geometry is that it's far less computationally heavy for your computer to render. In other words, if you had 1,000 NURBS or subd circles, and your computer was starting to get laggy in the way that it displays, then you might want to consider turning them into mesh geometries because they're much faster and easier for your computer to display. Now that we've covered all of these topics, let's get started with modeling. The first thing that I'm going to do is create a new layer to model on, and we're going to call it railing. I might make this a light shade of green. Next, I'm going to turn on my Pavilion roof layer and sphere geometry layer, and then turn off the thickened surface layer so that I can select this geometry. I'm going to copy this geometry onto the new railing layer by right-clicking on the railing layer and specifying to copy objects to layer. Let's hide the original layers, and we should see our green geometry. I'm then going to use the trim command to trim the roof, then hitting enter. Then let's use this flat geometry to trim the dome shape. I might also change the shade of this green to be a little bit lighter just so that it's not as harsh. I'm now left with just a few surfaces that I'm going to select and to use the join command to join together. Let's now use the extrude surface command and extrude it down by 12mm. I'll do this by dragging the shape down and typing in 12 before hitting enter. This was supposed to extrude as a solid, but there must have been some sort of error. Again, sometimes this happens, and I want to teach you to be resilient so that you can problem solve these errors. You can see that this is missing the roof, and if you've had this error too, what you can do is copy the geometry, then undo the extrusion so that we have the original shape that was missing on our extrusion. And then let's paste the extrusion back in. And join it all together. Now when we select it, you can see it's specified as a closed poly surface in the command bar. Now, the next thing we're going to do is make a subd out of this. You can see it has terrible topology at the moment, so we aren't going to use the command toSubD just yet, because first I'm going to teach you a really useful workflow to develop a subD from what we've already created with an excellent topology, so that you don't have to model it all from scratch. The first thing that we're going to do is turn green geometry into a mesh. To do this, we're going to type mesh into the command bar. You'll see that a window with a whole bunch of options will turn up. The main setting for this is to set either fewer polygons or more polygons. This basically sets the resolution of the mesh, so more polygons will make an object with many small faces, which will have a much larger file size and a much higher resolution, whereas fewer polygons will have a much lower resolution because the faces are a lot bigger. We'll choose roughly the middle value and hit OK. You'll notice that creating a mesh doesn't delete the geometry that we created, so let's select the original polysurface and delete it so that it's just our mesh left. Now you'll see that this mesh has terrible topology. All the faces are different sizes, there's no clear flow to the arrangement of the edges, and randomly changes between having triangle and then quad faces. Rhino now has a fantastic tool to deal with this that saves us exporting the model to another program called ZBrush to fix up the mesh. This tool is called Quad Remesh. Let's type that in and hit enter to see what this does. You'll see that this window pops up and shows some settings. The main settings that we'll be focusing on are the target quad count. This defines how many faces will be in the mesh, so similar to when we made the mesh, this is also setting the resolution. Let's hit the preview option and then the hide option and see what it generates. You can see that it's generated a much cleaner topology with similar sized faces and edges that are strongly aligned with each other. There are too many faces to be easily editable, so let's bump it down to maybe 300 faces. However, now there aren't enough faces to edit it easily. Maybe 750-ish would be better. What we're looking for is a topology where we can easily select all of these edges along here to sculpt up a railing. 750 seems to be the sweet spot on my model, so let's hit OK. You'll then notice that this won't delete out our last mesh, so let's type in cell last to select the remeshes mesh. Then we can use the hide command. Now let's select the original mesh and delete it and hit enter, then hit show so that we have our clean mesh back. We want to turn this into a subD to make it editable, so what we can do is select the mesh and use the command toSubD. Let's just turn on the delete input command and hit enter. Now we can go about modeling our railing. This will take a little bit of practice, but let's try to select the faces around the edge. I'll hold the Control and Shift key to select the faces at the end. Then at the other end, I can double click within that loop to select the whole loop. And then I'll do it with the bottom loop as well. We can then use the command extrude subD to extrude these faces off in their normal directions. We just need to specify a distance, so maybe we can specify 10 millimeters or so. Then hit enter. Let's now use those selection settings that we've learned to adjust the edges and faces so that the extrusion is better proportioned to the surrounding edges. Sort of like this. This can be a bit finicky at first to learn, but you'll become extremely proficient soon, and you'll be able to do this very, very quickly after a little bit of practice. So it's really important to actually get that practice here by doing these exercises. With that extruded, I can go to these new faces that have been created up the top, then hold the Control key down again, and move it upwards to extrude upwards. I might just need to smooth out a few of these edges as well once they're extruded. This is where it can be helpful to change between the smoothed and polygon view by hitting the Tab key. Getting little details like this right are a really good way to continue to practice using that Gumball tool. And once we're finished making that exterior railing, we're going to move on to creating a railing in the center circle. Again, similar to last time, I can select one face holding Control Shift. Then, while holding those keys down, I can double click on the adjacent face to select the whole loop. This time, I'm going to hold the Control key, but scale it inwards instead of moving it. If I hold the Shift key as well as the Control key, it will extrude inwards uniformly. I can then select the loop above here and extrude it upwards as well to generate an interior railing. Now I can go back and model the other two sides of the stairs that haven't been modeled as of yet. This uses the steps that you've already learned, so I'm not going to show you how to do the exact same thing twice in a row. So if you can't remember the commands to add a railing to the other two sides, then just go back and watch the same steps from the last railing and apply it to the next two. Once you finish that, you'll be up to speed and continue to follow along. Now we have our pavilion design, but I think I want to add some casual seating. I'm thinking we could make a bit of a contemporary version of the seating of the Greek amphitheatre, like the Atticus Theatre in Athens. I think I'll do this by drawing some curves and then lofting between them. So let's start by drawing the outline of some of the traditional seating like that. I'm going to draw a 2.5mm long curve and then hold the Shift key and draw it out at 90 degrees. Then I'll do another 2.5mm long line, but in the other direction, and hit Enter. I can then copy these up and maybe make 7 segments. Then hit Enter. I can then draw out the top roughly this size and take the other stairs and copy them over here. And I can use the Gumball tool to invert that shape by -1, which will completely flip it. Now let's use the move command to move it into this position, and then I'll select all of the curves and join them together. If it's a bit hard to follow those instructions, basically just make a curve that looks like this, because that's what our seating's sort of going to look like. With the curve selected, I'm going to use the rebuild command. This rebuilds a smooth curve with a particular number of points, which I might set at 100, so that it's smooth but doesn't lose its shape. I'm then going to lock all of these other layers so that I can move the curve into position without all of the other shapes annoyingly getting in the way of me selecting and moving things around. I'm going to roughly move them into this position with one in the middle of the stair, slightly raised so it's almost protruding entirely from the ground. Like this. I'll make sure that it's symmetrical right in the center of the pavilion. And then use the Gumball tool, holding the Alt key to copy 2 curves to either side, which I'll then rotate and move downwards just below the base, like this. And then I'll copy it to the other side so that we have 2 curves. And now I can loft these curves together to make some casual, basic, aesthetically pleasing, if not that ergonomically effective seating that's probably more likely to be used as a skate rail or a ramp really, but it sort of suits the vibe. I can then unlock those last layers that I unlocked earlier and select this top surface holding Control and Shift, which I can then use to trim that bottom lofted surface like this. I want to copy the seating to be under the other 2 staircases as well, and to do this I can use the Rotate tool by typing in Rotate and hitting Enter. I can go up to the top and turn on the copy option so that it'll copy out duplicates rather than moving the original. And it's asking for the center of our rotation. I really want it to be at the center of the model so I can roughly guess where that is with my mouse, or like earlier, we can type that in exactly. The way we do this is type 0, 0, 0, like we did last time, meaning it's 0 in the X direction, 0 in the Y direction, and 0 in the Z direction or axis, and then hit Enter. Now it's asking for an angle, and I'm going to move it exactly 1/3 of the way around, which is the equivalent of 120 degrees. So I'll type in 120 and then hit Enter, and see it's copied it out. I also want to copy it 2/3 of the way around, which is 240 degrees. So I'll type 240 and hit Enter again. I can hit Enter once more to finish the entire rotation command. You can see that since this has been quite a quick freeform modeling activity, that it's not exactly in the right place because it's not entirely uniform. So we're just going to adjust it a little bit so that it's in an ideal placement. I might also adjust the topology a little bit of the pavilion so that everything sort of fits together a bit better and is a little bit more uniform. Again, since this is relatively quick and freeform modeling, it's probably really good for you guys to get an opportunity to adjust things and for things not to be entirely right. We never really expect everything to be perfect from the get-go, so it's important to learn how to problem solve with it and adjust things as you go along. People give a model a perception of scale, and it also shows how you expect a model to be utilized. There are a few principles that I like to follow when adding people. Firstly, don't make them distracting, and secondly, don't make them generic. Make sure that they're engaging with what you've designed, and also make absolutely sure that they're at the right scale. I think it's always better to have a degree of anonymity in the choice of people so that anyone, regardless of culture, personality, gender, ethnicity, etc., can always imagine themselves or their community within that space. That's why at the moment I prefer to use stylized models here rather than those uncanny valley looking photoreal people that you sometimes see that look a little bit plasticky and can be a bit distracting. I'm going to use these models here which I've created. I've got them on my website which you can download for free via the link in the description. If you open the file up, you'll be able to copy the geometry across from one file into the other. Just copy it to your clipboard and then paste using the Ctrl-V command. If it doesn't seem to copy over into your file, you can use the zoom selection or zoom extents command, which is a magnifying tool I introduced to you earlier, to see if you can find it. It's probably copied in and it's just in a different location to your model. Now that we've copied all of these people in, I might lock the other layer to make it a bit easier to move around. At the moment, the people are scaled at 1 to 100, so we're going to use the Gumball tool to roughly scale them so that they're proportional to the project. It's really important to get the proportions between the people and the surroundings like the stairs correct. Be really careful when you're adjusting the scale, because if it's not right, it'll make the image look really off. And it's something that I see people do all the time. People tend to put many copies of figures across their site. However, when you've got heaps of elements copied again and again and again, you'll notice that it makes your file size grow considerably and tends to make the display a little bit laggy. I can show you a quick tip to keep the file size down when copying many things over and over again. This is to save the people into what's referred to as a block. To explain what a block is, I'm going to create 10 copies of some of my figures. You'll see that each of these is an individual mesh that I can select a face on and model individually. This means that I have 10 copies that will save 10 times over, in effect, making the file 10 times larger than just having one figure. I'm going to delete these duplicates and start again, but first I'm going to use the block command and convert this mesh into a block. It asks what objects I want to put into this block, so I'll select the figure and then hit enter. It then asks for a base point, so I'm going to select the figure's feet and hit enter. And now I can name it and give it a description if I want to. You'll see that now when I select it, the command bar will tell me that I've selected a block, not a mesh anymore. A block isn't its own type of geometry. Instead, what it does is create a reference of all of the geometry that's inside it. So in this case, it's created a reference of the mesh figure. If we duplicate the block 10 times, instead of saving that data 10 times over and making the file size 10 times larger, what Rhino will do is that it'll save the information of what one block is and then references it to 10 different points. So even if I had 1,000 duplicates, then the file size would stay the same as if I had one. If you want to copy these blocks individually, there's another way to insert them into the model. You can use the insert command. This will show you a list of all of the blocks that you've created in your model. If I chose the figure that I created earlier and hit OK, I can insert the block into any point I want. You'll notice that it inserts from the base point that we referenced earlier. One important thing to note about blocks is that you can't edit a block without affecting every other instance of that block. For example, I can't simply go to the figure and hold Ctrl-Shift to select a face to edit with the Gumball tool. If I want to edit a block, I need to select a block and then type in the command block edit. Now I can individually edit the faces. You'll see in this window here, if I now click OK, then any edits that I've made will affect every other block. Although I can't individually edit blocks, I can scale them individually. Just a precaution though, if you scale it non-uniformly like this, you'll no longer be able to use the block edit command. You'll need to use the block reset scale command to put it back into its original proportions before you can edit it. If you don't want something to be a block anymore and just want the geometry, I can use the explode command, which you're already familiar with, and this will explode all of the geometry out of the block so that I can edit it individually. But this will make the file size larger because it's not a block anymore. Great. Now that we've covered that, let's start placing our people around the scene. You can just use the Gumball tool and move each of them individually. Keep in mind what I mentioned about having people actually interact with your architecture in the way that you foresee them to in the future. Try not to have them just generically walking around or placed in random spots. This is another good opportunity to familiarize yourself with the Gumball Move and Rotate tool. While I'm moving these people around and placing them in the scene, I might point out that during this exercise we've been using a really peculiar scale, and the reason for this is that we're not actually modeling a pavilion, we're modeling a scale model of the pavilion, which I then want to fabricate. The design was produced as a part of an architecturally inspired sculpture series, which went live on the Legacy Design Studio artwork and sculpture page. I thought it might actually be fun to produce a sculpture related to every learning resource that I released. So if it's been a while since this video came out, maybe it might be interesting to see what I've produced since then. Unfortunately, this series is already sold out for the moment, but hopefully after I cross off a few more learning resources from my schedule, I'll find the time to develop and design a new series of sculptures. I'm actually really looking forward to the next series because I'm planning on designing them from a sophisticated interlocking parametric facade system. Maybe check out the website and see what I've come up with since this video went live. And for anyone that wants to support free learning resources like what you're watching at the moment, maybe consider them the next time a birthday or Christmas rolls around for someone close to you with a keen interest in design. I also just completed a series of Linework drawings at A1 scale for a Grasshopper tutorial series that I'm working on at the moment. These aren't actually prints, they're Linework drawings that are drawn out with pens robotically, and each one has 30,000 individual lines that are drawn pretty exhaustively over a period of days, but that's what's really necessary to develop the detail in these drawings. Because of the physical medium of the pens and the thick watercolor paper that they're drawn onto, these develop a really beautiful, unique texture to them. I actually have one hanging up in the back of my office at the moment, so have a look and see whether the series is still available on the website if you're interested and want to support these learning resources. They tend to sell out pretty quickly because they're pretty arduous and intense to produce at such large scales. Anyway, for now, back to the issue of fabricating our model. If we look at our model at the moment, it isn't optimized to be 3D printed yet because it's made up of many individual pieces of unjoined geometry, many of which aren't closed three-dimensional shapes. Luckily, Rhino 8 has an excellent command called Shrinkwrap, which generates a watertight mesh around any meshes, NURBS, sub-Ds, or other geometry that you've got selected. If we select everything that we've created and then type in Shrinkwrap, this window of options will pop up. Let's start by setting the edge length to around 3. This is similar to setting the resolution, where we have a smaller number, there'll be smaller faces, and a higher resolution. I'll then hit this preview option, and then hide input object option as well. You'll see that this will generate a mesh for me that's quite low resolution and loses a lot of the detail. I think I'll set the resolution closer to 0.4 because if I set it any lower, I'm worried it might actually make the file crash because it'll be too large. I can then hit OK and see that it's generated this shrink-wrapped mesh around my model. I'm going to put this into its own layer and hide all of the other layers. I might call the layer or shrink wrap and then change object to layer. And then I can hide all of these other layers. So now that you've learnt your modeling tools, I'm going to focus on teaching you a few ways to create really effective visualizations, animations, and documentation. We'll be covering creating basic rendered views, creating and applying materials, mapping those materials to objects, setting up lighting in your scene, creating diagrams and annotated documentation, as well as some quick animation workflows that will allow you to produce some really exceptional cutting-edge work in the future. So, to get started, I'm going to recap that you have multiple ways of displaying your model, which can be accessed by clicking on the Display tab up the top left of your viewport here. The main ones that you may use are Arctic, Monochrome, Pen, and Rendered. We'll also touch on Ray Traced later on in the render section. Let's stick with Rendered for the time being because this viewport will allow you to preview materials. I'm also going to hide the Shrinkwrap layer and turn back on the individual pieces of geometry so that the people, railing, thickened surface, and base are all visible, because we're going to be applying materials to each of these layers so that each object has its own individual material based on the layer itself. The first thing that we're going to do in terms of creating visualizations is choose some views. You can use the named view window to save your current perspective. All you need to do is orientate your viewport and then hit this plus icon up the top of the named view and then name it. I might call this perspective 001. When you're making your views, you have a few useful tools. Firstly, you can go to the properties menu, and as long as nothing's selected, it should show you your camera settings. These settings mimic those proper professional cameras with real lenses. For those of you that aren't familiar with handling these, basically if you have a lens with a lower lens length, let's say 22 millimeters, it will stretch your view to make everything to appear more expansive. However, if you set a longer lens length of say 90 millimeters, everything will feel much flatter. Using shorter lens lengths can be really useful for interior shots to get everything into frame. Try to be really considerate in the way that you apply these settings though, because you don't want something too low that has a really stretched fisheye effect like this. As a side note, some people use these tools to trick people into thinking that a space is a lot larger than it actually is. This is typically done by real estate agents and some developers selling shoebox apartments with really wildly spacious imagery. I find it pretty disingenuous to create visualizations that lie about a design's real-world characteristics, so I'd implore you to always be honest in the way that you represent your designs. Okay, back to our views. I might create one more view, sort of, yeah, like this, and I'll call this perspective 002, and one more over here, and I'll call this perspective 003. You can also use a command called isometric. This will give you a standard projection method at a specific angle, which, to be technical, is 30 degrees above the horizontal plane and 30 degrees from the vertical plane. When you use this command, you can choose which side you want to view it from, like this. If you want to undo the changes in your views, you can use the home and end key on your keyboard to cycle through them like this. Okay, with that done, let's get to applying materials. If you type in materials into the command bar, it'll bring up your materials library. As you can see, there are currently no materials in this file. Let's create one. To do this, push the plus button up the top right. It'll give you a whole bunch of presets for different types of materials, but for the purposes here, let's create a custom material. Now that we have material preview, which we can make larger or smaller by dragging this slider over, below that we have material options. The first option is the name, so let's just change this from custom to material 1. Below this are the material settings. To preview this, let's apply these settings to the model. The first way to apply materials to your model is by selecting a piece of geometry and then going to the menu and right-clicking Assign to Objects. You can see that this material is applied to an object by going to the Properties tab over here and then going to the Materials tab. Here you can see our material is applied. If you don't have a Properties menu, just type in Properties and it'll come up. We can also change the material choice here. I'm going to change it back to Use Layer Material so that it doesn't override the material layer. This is the next way that you can apply material. Rather than applying materials to objects individually, you can apply them to an entire layer. And this will affect every object on that layer. So if I go back to my material window and right click on the material, I can select the option that says assign to layers of objects. When I do this, we can go to our layers window and see that the material has been added to that entire layer. So let's start building up that material. The first thing that will change is the color. If you click on the white swatch, it will bring up the color menu and you can select which color you want the material to be. So I might set it to be a reddish pink color. There's also an option to assign textures like this. This can be useful if you want to reference an image of a material. So materials like stones, timbers, textiles, leathers, and so on. When you find these images, make sure that they repeat seamlessly. If they don't, then it'll stuff up your model because it'll look like this. I'm going to create a few different types of materials and then apply them to each element of the pavilion to create more of a diagrammatic visualization. This would be the type of visualization that you might annotate to list out what each part of the structure is. Let's now adjust our layers so that they're more organized to apply materials to. I'm going to create a new layer called materials and then move all of my layers that have objects that I want to apply materials to that layer. I'm then going to create some different materials to apply to my layers. I can actually create materials by clicking down here in the layers menu and creating materials directly onto that layer. I just need to click this plus icon here to create a new material. I'm going to choose a custom material again and change the name of it to associate it with that layer. So for this one, I'm going to call it staircase material. I can then go through and change the settings, so the color. I might choose a purple and blue color scheme for this. And I'll click OK, and you'll see that the material has been applied. I can also create materials in the same way that I showed you earlier by clicking this plus icon up the top here. So I might call this material the seating material. And then the other way to apply materials to layers is that I can select an object in the scene and then go back to my material in the material window and then right click on a particular material and say assign to layers of objects. And if we go to our layers down the bottom right here, you'll see that it will be applied to that particular object's layer. I can then go through and change a couple of the settings. So I can change the reflectivity value. I can also change the gloss finish, but you'll notice that it doesn't actually change from this menu here. You have to change the reflection polish down the bottom. I can then go and create some more materials by clicking the plus icon up here and saying custom material. I might change the color for this one as well and make it more of a blue tone, and the reflectivity and the polish values. And then I can rename this to base material and apply it to the base layer in the same way that I applied it earlier. I'm going to do the same for the railing layer as well, but I've already got this material. I can see it in the layers down here. So I'm actually going to go to the existing material and rename it to railing material and change around the color and polish settings just to refine it a little bit. I'm then going to fine tune all of these colors and the reflectivity values of the different materials so that they're analogous to each other. Without going into too much detail, this just means that they're all relatively similar to each other and it doesn't create a chaotic mess of materials. It's also important to me to actually create a sense of hierarchy in the images, so that's why the largest elements are a more dulled out, desaturated color, whereas the smaller elements that you might not necessarily notice are going to be a much darker, more saturated material so that it draws your attention to it. You want to fine tune these based on the overall color scheme of your project, but for now this will sort of do for us to explain this as a conceptual image. The other thing to note that's important is that if we go to the top of our model, a few different objects intersect each other and it creates this camouflage effect. What I can do to fix this is actually just change the positioning of one of these elements so they don't intersect. So I'm going to hold Control Shift and then select the top of this stair, and then I can go to the Gumball tool and press the up arrow and then input an exact amount. I'm going to put in a really small amount, so 0.5 millimeters, and hit enter. And you'll see that it doesn't intersect anymore, and you don't get that camouflaging effect across the two different materials. Now that the materials are created and applied to each layer, I might be thinking that I don't like the way that the background looks. Maybe I prefer the style of the Arctic background more than this. But if we go to Arctic, you'll see that this removes the material appearances as well. There are two ways to change this. You could either go into the Displays property menu and play around with the display settings. However, a much quicker and I think more useful trick is to select the geometry in this view and use the command Set Object Display Mode. Now, if we go to the command bar, we can actually change the display of each of these objects in the scene. So I can have the environment and any other elements that I want to be displayed in the Arctic display properties, and then have the pavilion displayed in the rendered display appearance. You could do this with as many objects in the scene as you want. Now, to save out the views, you can use the command called View Capture to File. This will actually let me save a screenshot of my viewport, which can be really handy. You'll see that it brings up this window with a bunch of settings. The most important settings are whether you have the transparent background turned on, and also the resolution. When you choose which file type it is, just remember that JPEGs can't save a transparent background, but PNG files can. I'll go into more depths about this later when I show you how to render images properly. I'll call this render 001 because it's important to keep organized continuity between files. And then when I go to open up the actual image, this is what it will look like. And you can import this into Photoshop or whatever graphic software that you're using. Now, what if you wanted to make images that are more photoreal? Well, Rhino has a comprehensive inbuilt material library, and to access this, we can type in the command libraries and then hit enter. Then the libraries window will pop up like this. You can see here that there's a whole range of inbuilt materials that are grouped by category. Before we start exploring the library, I'd suggest to everyone to go to the menu up the top right and click Download All Library Textures to deal with any missing library files. It might take a little while. If you don't want to constantly look up materials by category, then you can also search for materials. Just note that it'll only search for materials in the folder that you have selected. For example, if I wanted to, I could search for all of the concrete materials that are in this file. Then to apply the material, I can select the pavilion and the stairs, then go back to the menu and select the concrete light material. If I right click, I can tell it to apply to these objects and it will automatically import it into the scene and apply it to the pavilion. You'll notice that the material looks terrible when it's applied. This is because it's at the complete wrong scale. To change that scale, we need to map that material to the object. There are a few options for this, and Rhino's just released some much more detailed UV mapping tools like the floating UV editor. This allows you to unwrap a surface of an object and map it onto a preview of the two-dimensional texture. These detailed techniques sit outside the scope of this architecturally focused tutorial, but do let me know if you wanted me to cover them in more detail in a more in-depth video. Let me know in the comments below. If we select the object, so we just applied the material to, and then go to the properties window located over here, or which you can access via typing in the command properties, you'll see that next to the materials icon, which looks like a paint tube, there's a checkered looking cylinder. This is the materials mapping properties. You can see that the first thing that turns up is an error, and this is because by default, many of these materials in the material library will have mapping methods already applied to them for different geometry types. See here how this error references WCS? This means World Coordinate System Mapping, which maps materials according to their position in space using a box. However, since our model isn't at a full scale, it's easier to work through this by applying custom mapping. So for now, just click here to fix this automatically and it'll take care of this issue. The main mapping type that can be utilized for 90% of high quality general architectural rendering is box mapping. If we select the box with a plus icon here, it'll prompt us to make a box. The size of this box will determine the size of the texture being applied across the object. So if I drag out a big box like this and hit enter, the texture placement will be really big. Whereas if I do it again, but on a lot smaller scale, then the texture placement will be smaller. We can also set the mapping more precisely by hitting the box map icon. Then selecting the base point, followed by putting in a specific number, perhaps 30, and hitting enter. It will then ask us for the width, so we can put in 30 again and then hit enter, then 30 again for the height. It then asks us if we want it capped, and we can say yes, or just leave it and hit enter. If you want to edit this mapping in a visual way, then we can hit the show mapping icon here. This mapping widget allows us to move, scale, and rotate the mapping. This can be particularly useful for rendering with things like bricks because it requires a lot of effort to get the alignment of the mortar right, so there aren't a bunch of weirdly sized and cropped bricks over the place. I'm now going to add materials to the other elements of the model, so I'm going to select the seats and then maybe apply the concrete dark material, which has a bit more of the formwork exposed. I can then go to map these. You'll notice that immediately after applying the material, I won't be able to map it. Every time that I go to apply one of these PBR materials, it'll come up with this error again. So every time you apply one, you just have to click here to fix this automatically. Now I'll go back and I'll apply box mapping again at a size of 15 this time. You'll see that this doesn't look great because if it was constructed in real life, the impressions of the plywood formwork would follow the flow of the overall shape. So what I might do is actually change the mapping to surface mapping. This mapping type won't follow the flow of the box, instead it will stretch across the surface. At the moment, it's at the wrong scale because it only repeats once over each of these surfaces, so to increase these repetitions, I'll go down to the repeat option and click the lock button. This will mean that it repeats uniformly. Then I might set it to repeat 20 times. Now the scale looks right, but it doesn't really flow across the surface correctly. So what I can do is rotate the texture by 90 degrees as well. This will look much better now because it follows the flow of that formwork. I might apply a material to the base now. I'd suggest to each of you to explore all of the materials in this library. You'll see that textures like this grass looks pretty terrible because they're not actually 3D elements like you can produce in other renderers, such as using a firm material in V-Ray. Even though this material isn't what it's intended for, I think I might use a cast iron reflective material, which I'll then assign to the base and ensure that it's mapped correctly as well. I might use a box mapping of 30 by 30. If you're feeling pretty sick of brutalist architecture at this point, feel free to add any materials that you want to it, whether they be timbers or paints or ceramics, whatever you want. Maybe you might want the work to feel more colourful, so you could look up work by Bernard Toshimi, for example, and add some red paint materials to mimic that. Maybe you want it to feel more metallic, like the Lloyd's building by Richard Rogers and Partners. Maybe even look into your favourite material palettes from movies, because they tend to offer a pretty rich source of precedence. The visualizations you create don't have to feel photoreal either. You could make it out of matte plastic materials and see if you can mimic the material texture from the Disney movie Up if you really wanted to. Now that the materials are sorted, we should address the fact that the model currently looks like it's floating. So to get it to cast some shadows, I'm going to turn on something called the ground plane. You'll see that this window pops up, and I'm going to select to turn it on. Let's also change the display mode back into rendered display, just so that there's continuity between all of the settings. Then I can set the height manually to be right under the pavilion base. This affects where the ground plane actually starts if you wanted it to be a little bit higher, but at this point my model is actually at 0, so everything's okay by default. I can also specify a material rather than just having it as a generic white color. I might have a look through the materials library for a nice metallic aluminium material, something that's going to have a little bit of reflection but not too much. We can slide through here and have a look through them all. Maybe this satin aluminium might be appropriate. Instead of applying the material to a particular object this time, I'm just going to bring it into the material library. It might take a little time for it to import for the first time, and then we can go to our ground plane settings and we can apply that satin aluminium material. The next thing to do is add a proper lighting setup. Although the rendered view that we're currently in is good for viewing what materials are applied and how they're mapped, it's terrible at showing the lighting conditions. To do this, we can use the ray trace display settings. This uses a component in your computer called the GPU to create highly realistic images of your model in the lighting conditions that you've set up by simulating the behavior of individual rays of light bouncing around the scene. I will note that Rhino has improved the render engine in Rhino 8 and should run on most computers that have come out in the last couple of years, as well as most Macs. However, I am aware that some computers may struggle or outright not be capable of displaying this viewport. If this is the case, then you're still able to do a final render, you just won't be able to preview it in the ray traced view. So keep watching and do your best to follow along in the render display rather than the ray trace display for now. If you are interested in learning everything that you need to know about computers in the design profession, then make sure that you subscribe and turn on your notifications on YouTube. And if it's not on YouTube yet, then maybe check the Legacy Design Studio website, because I'll upload it there to get feedback before I publish it to YouTube. The link is in the description below. If you're noticing that this viewport is a bit unresponsive, you can always minimize it so that it's got a smaller amount to actually display. And you can also have two views operating at once, so one in shaded view below and the ray traced view above. And you can preview changes like that, so that you don't have to worry about it not being responsive. You'll notice that I can still make changes to the geometry in this view, but it's a bit annoying how it takes a while to get rid of the noise because it is actually rendering this out. To show you what I mean, I'm going to make one more change to the geometry, which is going to make the base a whole lot thinner using my Gumball tool like this. I'm going to go down to my front viewport over here because I can more easily make changes to the height. And then I can use the invert tool and select all of the other geometry and move it downwards like this. We can see now that it fits much better on the base like this. If we go back to render view, I want to show you that if I choose a material like this frosted glass and apply it to an object in my scene, it will look really terrible. This is because rendered view takes shortcuts so that it's able to render out at a really high FPS or frames per second. However, when I go back to ray trace display, which actually simulates the flow of light properly, it'll look dramatically better, and the shadows and tint of the light is really beautifully represented. This is because ray trace view is properly rendering out the flow of light through the scene. It's not cutting corners like the rendered viewport below does. The rendered viewport below is more like a video game display that cuts corners to be able to render out at hundreds of frames per second very, very quickly, whereas the one above simulates all of the subtleties and gives a preview of the subtle details of more complex elements of rendering, like the subtle tinting that's occurred through the frosted glass, or the refraction that's occurring because of the frosted glass surface. Having a look at all of the options for these materials can be a really useful way of actually learning about how to create your own materials rather than the more generic color-based materials that we created earlier as custom materials. You'll see that these materials have more sophisticated presets. They're not just like custom materials. This frosted glass, for example, you can impact the clarity or the index of refraction. Or if we go up to a concrete texture up here, you can see all of these presets that you can learn from. For now though, I'll undo this and get back to the concrete texture. To start making our own lighting, I'm going to type lights into the command bar. You'll see by default we have two lights that are available. The first light is the sun. If you double click on the sun label, it'll bring up the light window. So let's turn on the sun. And you'll see that you can either control it according to its position on Earth at a particular time, where you can get realistic lighting conditions, which can be really useful for shadow diagrams if you need to create them. Here you can see that I'll change around what time of the day it is, and you can see that it's linked to the temperature of the light, whether it's at twilight or dawn or dusk. You can also have manual control of this and move it about your model to visualize it. You can see here that this part controls how high it is on the horizon, and this part here controls the orientation of the sun. So I could have it either coming from the southeast or the southwest. I might just turn that off and exit out of this window for the time being. There's also a default light called the skylight. This light basically lights up the scene evenly. By adjusting the intensity of this light, it can help you adjust the intensity of the shadows and the softness of the light. So if I was to change the value from 0.2 to 0.05, you'll see that the shadows become much harsher because there's less even lighting, whereas 0.7 will have much softer lighting. If you want to make really realistic lighting, then we're going to need to utilize environmental or HDRI lighting. What HDRI lighting does is that it uses a stretched out sphere of an image that surrounds the model, and that's used to generate the lighting of the scene, but also the reflections on the materials. This is what's responsible for unrealistically lit elements in movies, such as the infamous Wolverine claw scene, where the claws feel totally fake because they don't match the lighting or the reflections of everything else in the scene. To set up environmental lighting inside of Rhino, let's type environments into the command bar and hit enter. You'll see that there's already one there by default. However, let's add our own, which can be found in the Rhino libraries window that we saw earlier. I'm going to look through the library and see if I can find a good outdoor scene. We can make all of these thumbnails a bit bigger by dragging that icon down there and just scroll through. I think this one will do. To import it, I'll right click and then click on Import to Environment Editor. Now that this is imported, I can click on it and say Set for all environmental channels. When these icons appear, they indicate that it's being used for the reflection, for the lighting, and as the backdrop in this scene. With the environmental light active, we can go to our lighting settings and start to adjust these settings like the intensity and the position of the sun to get the atmosphere that we're hoping for. It's a fine balance with this in terms of creating shadows and reducing overexposure and underexposure, so just play around with it. These are natural lighting types, but we can also start to implement some additional artificial lighting into the scene. There are a few options to do this. Firstly, we might want to make a sphere light, so let's go to the render window up the top and click the sphere light icon here, and then place it into the scene. If you're unable to put it into the scene or snap to any of the geometry, make sure that you have vertexes turned on in your OSnap settings down here to allow you to snap to meshes. At the moment, the light geometry itself is invisible in the ray trace view, so let's type in display properties into the command bar, which will bring up this menu here. This will affect the display settings, which can be really useful. We can choose to hide certain object types. In this case, we might want the lights to be turned on so that we can edit them. I might actually leave them turned off for the time being in this ray traced view. Then minimize this view and go to my lower viewport. Then go to the named view tab again and choose one of my views, followed by setting the displayed mode to shaded. Now this will let me edit in one viewport and see the effects in the other so that it's not laggy. With your lighting effects, there are a few principles to adhere to. Try to create some subtle shadows across the exterior of your pavilion, but don't overdo the intensity of the light and create overexposure. Leave it a tiny bit underexposed on the outside so that you can create a glowing effect inside your pavilion. There's no exact way to do this because each of your pavilions is going to be modeled with different orientations, so it's a really good opportunity for you to get some experience in implementing this type of lighting. I can now move this light into the position that I want, and then maximize the ray traced view. and adjust the lighting values in the light window. I can change the intensity, which is the brightness, as well as the shadow intensity. If I click this white swatch, I can also change the color of the light. Changing between a blue, white, and tungsten color light is referred to as changing the temperature of that light, where we can go from a cool colored light up to a warm colored light. The other light type that you'll typically use is the spotlight tool. I might make a spotlight here to make the skylight appear a little bit more intense. We can then play around with the intensities of the light and the color until we're happy. And after that, I'm going to rename each of these types of lights to differentiate in between them. With your lighting effects, there's a few principles to adhere to. Try to create some subtle shadows across the scene for the exterior lighting, but don't overdo the intensity and create overexposure. Leave it a tiny bit underexposed on the outside so that you can create a glowing effect inside the pavilion. There's no exact way to do this because each of your pavilions is going to be modeled with different orientations, so it's a really good opportunity for you to get some experience in actually implementing this type of lighting. We can also create some visual effects. I mentioned how Rhino can mimic professional camera effects in terms of creating depth of field. So depth of field is basically the blurring out of a background. If I was to put this closer to the camera, then you're going to be able to see how it blurs out the background heaps. And that's because it has a very low f-stop or aperture value. The f-stop of the lens that you're watching through right now is f1.4. So it's creating significant blurring out of the background, particularly if I come in closely like this. Generally speaking, lenses like this one here, which is capable of f1.4, is going to be able to create far more depth of field than this lens here, which is capable of f4.0. And we can have the same effect in Rhino. If you go to the properties panel, you can hit this setting here called focal blur. Once we turn it on, it will let us set a focal distance. I think it's easier if we set a point rather than setting an actual distance. So we can hit this point icon here. I'm going to set it to the person walking up the stairs so that I get a bit of differentiation in blurring effect between the foreground and the background, and then hit enter. Then you can adjust the aperture value. This doesn't exactly seem to act like an actual f-stop value as far as I can tell, but generally speaking, the smaller the value, the more the depth of field effect that there will be. So with an f-stop of 1, there'll be heaps. With an f-stop of 7, there'll be less. Generally, when you go past 7 on a real camera, it'll stop increasing the clarity, but in this case, the larger the number, the larger the clarity at every depth. You'll notice what's happening here is that it's creating lots of clarity around the exact point that we've selected. And then further back or further forward than this, it's creating a depth of field effect. So it's blurring it out based on the distance that it is from our focal point. Rhino sort of cheats with this because you can actually set multiple focal points, which you can't do with a real camera lens without using Photoshop at least, which can also be a useful feature to know. Once we're happy with all of this, we can go to our render settings by clicking on the blue dot with a hand on it just up here. Let's make our way through these settings. Firstly, we want to choose to render our current view, so that's okay. We can then select the resolution and quality. The resolution will specify the number of pixels that it generates. You may have heard some of the resolutions before. 1080p is the resolution of an HD or high definition monitor, whereas top computer monitors are referred to as 4K monitors, and they have 4 times the number of pixels. If you want to print these images on a poster, keep in mind that printers can typically achieve a much higher resolution than what you can typically see on screens. I won't go into too much depth about this, but they can usually print between 600 and 1200 dpi, or dots per inch of print space. So if you're printing, you should always bump up the resolution compared to if you're looking at it on a screen. My 1080p monitors back there, for example, can only achieve 81 ppi, meaning pixels per inch, so 81 versus up to 1200 for printing things out. You need to make sure that there's much higher resolution when you're printing to make your lines look really, really sharp and to make the images not look pixelated, because you'll be able to pick this up when you actually look at the poster. It just won't look as clean if you're not printing it at a much higher resolution. You can also set the image quality. Setting it low will make the render finish fast, which can be used for test renders. However, for the moment, let's try final quality, which will be the highest quality. This will get rid of the grainy effect that you sort of see at the start of renders. Other than that, we might want to set the background color. You can see at the moment that the background is actually from the environmental image. We can override this by selecting a color, and we might make it a little bit gray. Might just tweak this around a little bit. Our lighting and ground plane are already set up. And the other settings aren't really relevant to this render. Rather than using view capture to file this time, we're going to actually render the image. Rendering is a way of actually simulating the flow of light through a scene to create a much more photo accurate and high resolution image. Because of this, it can take some time to actually render compared to looking through the rendered viewport, which is almost instantaneous. Before we actually render this image out, I might just have a look through our named views just to check what the strongest view is. I'd encourage you all to actually try to create some new views as well to practice your compositional arrangements. And then I might tweak this view just so that the composition is really optimized for what we've now set up in terms of lighting and shadows and telling a story with the people that are going through the scene. So to render, what we do is just click on this render icon down the bottom left here, and it'll just take a moment for the render window to actually pop up because it needs to load all of the geometry and lighting into the scene before it starts to render. You'll see down the bottom that it brings up how many samples have been completed and the time that's lapsed. This will automatically finish at a designated number of samples. So for final render quality settings that we've specified, that will be 1500 samples. Ordinarily, we would let this finish, but for the time being, I'm sort of happy with the quality as it stands. So I'm going to stop the render with this big stop button up the top. You'll see that now we have this render window with a whole bunch of options. There's this effects menu that you can play around with. You can also go to tone mapping and adjust the colors. This can be useful to generate some minor adjustments, but generally you want to do all of your editing in Photoshop and Lightroom. To save the image out, just hit the save icon. You'll see there are multiple file options. The main images that you'll work with are either JPEGs or PNGs. JPEGs are compressed images that reduce the file size, and I won't go into too much detail, but it allows you to keep the same resolution, but just give up some of the clarity and color accuracy. A part of this compression also means that you can't have a transparent background. PNGs are slightly less compressed and allow for transparent backgrounds. You can use TIFF images too. TIFF images aren't compressed really at all. They also allow transparency, but this is at the cost of having much larger file sizes. You'll also notice that there are these other icons. Most of them aren't really important, like isolating color channels. However, the one called distance channel can be hugely useful for editing in Photoshop. You can also preview this in your Rhino viewport by typing in show Z buffer. This can be useful as a visibility setting if you've got lots of objects in your model and can't see them very clearly. We can type show Z buffer again to go back to our normal view. The other option I might mention is EMAP. This lets you choose an object and then apply a reflective film to reflect the environment. I would just note though that it's probably not going to work in your ray traced view or your rendered view, so let's go to shaded view instead. It can be really useful to see the textures and the shape of surfaces that you're modeling, sort of like how people put cars into very particular lighting conditions to do paint corrections on their surfaces. If you exit out of this EMAP window, then it'll cause the preview to stop. As well as creating still imagery, we can also pretty easily create animations in Rhino. Let's first enter into the monochromatic view. It might take a few seconds for this to load up. Let's then type in isometric and choose one of the orientations to get a better composition for our image. You can see that you can change through between northeast, northwest, southeast, and southwest. This won't really matter for the moment because we're going to turn on a command called turntable. This will rotate your model in real time. You can then set how quickly it rotates around using this slider. If you want to exit out of it, you can just press the escape key. But you'll see that it'll create a rotating view like this. It might be helpful for some of your future work. If we want to export that animation, we can go to the render toolbar up the top and there's some animation settings. To create the animation, the first thing that we need to do is set it up. Then we can render it afterwards. To set it up, let's click on these animation tools and check the Setup 360-degree turntable tool. We can then apply some settings. Firstly, it asks for a frame count. Without getting too technical, most videos hover around 30 frames per second. So if we want our animation to go for 10 seconds, we need to create 300 frames. We then choose what file types. JPEGs are fine. I don't really need a transparent background, and I want the image to be compressed to a relatively small size, so that's okay. I want the capture method to be monochrome for this, and then I might name it 001 just so I can make the file names consistent. I can then press the green play button to preview that animation. If you're happy with the preview, then you can press this record button here. You can set the file location up the top in the command bar here. So I'll create a new folder called Animation Stills and select this as my folder. You might also want to turn preview animation on so that you can see as it saves out each still image. Then hit enter and it'll start recording. See, it'll be saving out image by image. This might take a minute to save all of those images and work all the way through the animation, so I'm just going to skip forward a minute. When the animation is finished, we can go to our folder and all of the still images will be there. You'll then see that there's an HTML file here as well, and this will allow you to preview this animation in your browser. There are many ways that we can make this animation into a video file. The way you'll probably find easiest is to open Photoshop, then go File, Open, and choose the first image in that sequence that we just created. Make sure that the image sequence is ticked here, and let's specify 30 frames per second. Then you'll see that the Layers tab has actually imported this as a video group. To export this video, we go File, then Export, then Render Video. We'll then have all of these settings pop up, but I think it's fine for the moment to just leave it in the default settings. So let's hit enter and it will render this video out and save it into wherever we've specified. It'll just take a little while for it to actually render out. If we skip forward by a minute or so, I can show you in the file that it will render out as a video file here. See how it plays here as a video file? This means that you can embed it into any of the presentations that you might be making on PowerPoint or InDesign or even in video format. If you want to be introduced to a more professional workflow for animation, then you should definitely try out After Effects. It's an enormously powerful piece of professional software. If you want to get back to the Rhino portion of this tutorial, then just skip 1.5 minutes ahead. When you open After Effects, you'll see this screen. We can go New Project. And once it opens the main layout, right click here, go Import, and select File. Then select your first image, and make sure that this sequence option is ticked. This will bring all of the files in as one. See how all of these images have been brought in as a stack? You can then right click on the imported image stack and specify New Comp from Selection. If you hit the spacebar, you'll notice it'll play a preview. To export this, we simply go File, Export, and add to Adobe Media Encoder queue. In Adobe Media Encoder, you can change the settings like the file type and the presets. These should all be fine by default, so let's just specify where we want to save it. The point of using Adobe Media Encoder is that it's meant to export files outside of the After Effects program, so you can export multiple at once and still use After Effects. Let's hit play up here and it'll start the export process. It'll just take a little while for that file to render out, but you can see that once it does, when we go into this folder, there's an After Effects file here, and it's exported with more optimized settings than the Photoshop size, so the file size is actually a bit smaller. After Effects is an enormously powerful animation tool, which is well worthwhile if you want to get into professional motion graphics for your presentations. The other types of animations that we can set up are fly-through or path animations. A fly-through animation moves the camera along a single curve, but we can use a path animation to specify two curves. One curve to determine the path of the camera and one curve to determine the path of the target. Let's draw our two curves like this. The first curve, which is the largest curve, is going to set the path that the camera takes. And then simultaneously, whilst the camera is taking that path through the animation, it's going to be focusing on the second curve. So the bigger curve is the camera path, the smaller curve is the camera target. And then adjust them to roughly be this shape. We're adjusting it like this so that the camera moves from a bird's eye perspective into a closer perspective. Then we can set the path animation tool. It's this one here. Specify the curves we just made like this. And hit enter and apply your preferred settings just like we did last time. I'll just note that you should make sure that your projection settings are set to perspective and not parallel, or else you'll get some strange unexpected results in the animation preview. We can then hit preview in the same way as we did for the turntable animation, and it'll preview it out. If you want to record this animation, you can do it just like you did for the last one by pressing the record button and then setting the file output and hitting enter. Now that we've explored how to make professional visualizations and quick animations in Rhino, I'll quickly show you how to use the tools to document what you've created as well. Let's go back to our shrink-wrapped geometry for this demonstration and hide everything else because it's a closed geometry, unlike what we've just been working on. Firstly, there's a tool called section. Let's type that in and it'll ask us which geometry that we want to create the section through. Let's select our pavilion and hit enter. It now asks us where we want to create the section, so let's choose an interesting part of the model, maybe through both sets of stairs. You'll see that it creates line work cutting through the model. Let's make a new layer and put those curves into the layer. We can also make a section through a visualization. To do this, we can use a tool called clipping plane. Let's draw one out. Then, since it's flat, let's rotate it up by 90 degrees and move it around to see what it does. See how it clips and hides anything that it intersects with? What we can do with this is move it to where our section was taken. I might use the Orient 3-point tool to do this. Remember that Orient 3-point requires us to reference 3 individual points, so I'm going to put 2 along here on the clipping plane itself, and then 1 above it using the parallel view. And then I'm going to reference it to the section curve, straight across the top, and then also the point on the bottom. After this, I'm also going to go and rotate the clipping plane with the Gumball tool. And I'm just going to adjust the perspective. I might change the projection method from perspective to parallel because parallel projection flattens the image out a bit. From this, we can save our view in the named view. so that we'll always have a reference of it. I might call this section view. Then I'm going to change to a different display type. We could choose ray traced, but I want something a bit more diagrammatic, so I might specify the Arctic viewport. I might also go to my display settings and hide the clipping plane and the curves so that they don't show up in this view. And then I can save out this image with view capture to file. At the moment, it still looks pretty terrible though, so we can make a few quick changes to start to enhance the quality of the section drawing. Firstly, if we expand our Layers tab, you'll see that the settings for section style are there. It's just hidden over here to the far right by default, so we're going to drag it over. Let's change the section style for the objects that we're editing. Remember, if you select the object, it'll show what layer it's on down the bottom here. Let's click on the section style and it'll pop up this window. From here, we can change the hatch pattern and the hatch color. By default, it'll match the color of the layer as well as the line work of your layer, which you specify over here. I'm just going to cancel the hatching for the moment so that I can change them. If you click on the continuous line type, you'll see that all of these line type settings come up and you can change the line type of this layer. So if I wanted, I could select dots and press OK. And now we're going to have dotted edges. Or I could go in and press dashed, and then you'll have dashed edges. If I change the color of the layer itself to, for example, red, you'll see that it changes the dashes to red dashes. For the time being, I might leave it as a continuous line. If we go back over to our hatch settings, I'm just going to apply the settings that we had on previously. If we press OK, you can see that the hatch is set at a really bad scale. So I might change the scale value of this around to make it a bit more uniform. I might go back into the hatching and change the scale from 4 to something even lower. And then you may want to adjust your perspective as well to get a better composition of the section. You may decide that you don't like the look of the hatching, so we can change it to a solid color instead. And then in the color menu, we can go to other color and choose whichever color that we actually want. I might choose a dark gray, but maybe the dark doesn't look so good in the overall color palette, so I might change it to a lighter gray instead. When you start to apply these tools along with Make 2D, which is a really powerful tool that I'm going to show you in a minute, or even editing the line work individually in Rhino or Illustrator, you can begin to achieve some really exceptional effects like the work of Vitilia Bow Wow, who produce absolutely exceptional line work drawings. Rhino has a whole range of advanced documentation tools built into it, which I won't go into too much depth with, but I'll give you a taste of how you might utilize a few really useful tools. I might go to Named View and call this section 002. And then I'm going to go from the Arctic display mode to the shaded display mode. And you'll see that the clipping plane actually turns up again. If I don't want to show this clipping plane, I could type in disable clipping plane and it will disable the clipping plane. You'll notice though that when I go into my named view and I double click on the view I just saved out, it'll actually enable the clipping plane, and that's because named view saves the clipping plane presets. So I'm just going to disable it once again. If I wanted, I could copy the section curve that I made earlier. I'm going to use the Gumball tool to drag it across, and then I can use the Orient 3-point tool to orient it onto the flat plane. I'm going to select the base 2 points on this curve here, and then an additional point up top, and then go to my top view, and then hold Shift and place it on the flat plane so that I can export it. I'm going to use the command export, and it will prompt this menu. We just need to specify an Adobe Illustrator file type, and then we can name the view. I'm going to call this section Linework Illustrator. You'll be prompted with this menu, which either offers to give a snapshot of the current view or to preserve the model scale. Preserving the scale can be really useful if you've got scaled line work drawings that you need to be consistent with. However, for the time being, I can just use the model view and it'll export something that's not to scale. We can then go to the file that it saves to and opens up the Illustrator file, and you'll see that the line work exists in this file. You can then alter it in Illustrator however you want, so changing the line widths or the colors or line styles. You could add a photo with a clipping plane in the back if you wanted to, and build up a really exquisite, detailed, and sophisticated line work drawing. Not a lot of people know this, but Rhino is actually an extremely powerful and underrated documentation tool. I'm going to show you some methods that we can use to actually make documentation sets. Firstly, we can make our own drawing sets. Rhino allows you to create new layouts like this. I'll click this plus icon down here and specify new layout. Then I can call it Pavilion Documentation. I'll specify that I don't want any existing detail on it because I'm going to add my drawings to it. And I'm going to specify that it should be A1 sized in landscape because this is the drawing size that I typically find best communicate with builders and fabricators on site. This layout now exists in complete isolation of the geometry of the model. So if I hide things here, it won't hide it over there, but it does maintain the same layer structure and visibility settings. So if I turn off a layer here, it will also turn off a layer in my other view. Let's populate this layout with some drawings now. Firstly, I might go to the plan view and I'll find my pavilion geometry. I'm going to hide my shrink-wrapped geometry for this, and I'm going to show the materials layer that I hid earlier, because this will have all of the individual elements which will be better for creating line work drawings, as well as visualizations. I'm then going to quickly hide all of these curves and the clipping plane as well by selecting them and typing in hide. And I'll do the same for the lights. I'm then going to select all this geometry and use the command make 2D. Make 2D will make 2D line work of whatever we've got in our perspective or top viewport. When we use the command, we'll be prompted with this window which has a whole lot of options. A few important ones are to turn hidden lines off and to group the output. I'm then going to press OK. And it might just take a little while for it to make that 2D line work, so just leave your computer for a minute or so. And if we type in that command cell last to select whatever we've operated on last, and then use this zoom selection tool up here, then you'll see that it's generated all of this line work, which is also to scale. I'm going to copy it directly onto the layout. So I'll just click copy, and then go over to the layout and hit paste. I might move it to the top of the layout over here. I want to remember this scale, so I might create a text label for the drawing. To do this, I'll type in text and hit enter. Then specify a size for the text. I think 10 millimeters tall might be appropriate. And then I'm going to write scale 1:1. And then I'll hit OK, and I'll be able to place it. If you're not happy with anything about it, you can edit it in the future by double clicking on it, and it'll bring back up this option window. You can also add visualizations to the board, so I can go back to that viewport that I had earlier, and instead of typing in view capture to file, I can type view capture to clipboard, which will mean that whenever I paste anywhere, whether it's a Facebook chat, a Microsoft Word document, or into this Rhino viewport, it'll paste a screenshot of my view. View capture to clipboard has the same options as view capture to file, so let's make sure that transparent background is turned on. And then I'll hit OK. Now let's go to our documentation layout and paste it in. You'll need to hit Ctrl V on your keyboard to do this. You won't be able to go edit and then paste for some weird reason. You'll need to drag the image out, so let's do that. You'll notice that the image is created in the same shape as a viewport, but I want to trim down the edges. So to do this, I'm going to create a circle and then use the trim command to trim off the extra parts. You'll notice that the curves are also in the same colors as the layers. So to change this, I'm going to create a new layer. and it's going to relate directly to the documentation layout. So I'm going to call it documentation linework and create a sub layer called plan and put the linework on that plan layer. I'm also going to create a sub layer there called a view capture to file or view capture. And I'm going to change the image into that layer. I'm then going to move my image so that it's superimposed underneath the curves. You may want to change your Gumball reference from the object to the world so that it's in the center of your object. And then delicately, I'm going to move it so that it's exactly imposed over where the line work is. If you wanted, you could then go and change all the line work colors and styles and line widths to create a really sophisticated line work drawing from this. If you want to create annotations on this image, you can use the leader command. I can draw out an annotation like this and then hit enter. This will give me a window where I can put in text. I'll make sure that I specify the size, so maybe the text can be 8mm. The font might be good in Arial narrow and in all caps, because that's how drawing should be, because capitalized text is easier to read at smaller sizes, allowing us to put more information onto each sheet while still maintaining legibility. There are also more options below. I can make an arrowhead and maybe make it 4mm thick, and then when we're happy with everything, let's just click OK. I can also double click on this to edit it, and let's lock the background image so it's easier to select. The other really advanced thing that I want to show you is that Rhino 8 supports dynamic drawings in the same way that CAD softwares like ArchiCAD and Revit do. To utilize this, let's go back to our perspective viewport and then up to the drafting window up the top here, then to section, and then to create. It prompts me what objects I would like to put into the section, so I'll select this, and then I can then place the section. I might set the direction as custom so that it can go through the stairs. I can then place as many sections as I like, just as I would be able to in ArchiCAD or Revit. Let's just place one and hit enter. You can see that I can move and even flip the section if I wanted to. If I don't want a section to be active, I can just select it and use the command disable clipping plane. Then I might assign it to its own layer so that I can easily lock and hide it. If I want to turn the section preview back on, I can type in enable clipping plane. The amazing thing about this is that I can now go back up to drafting and then sections and then create drawing. We can now add this section to our drawing layout document in here. And you'll see that it's added it to its own locked layer. If you want to add the background to the section, there's a way to do that. We're just going to go back to the section and select it, then go drafting, sections, and then edit drawings. And we'll get all the options up the top to edit this drawing. We're just going to say add background and turn that to yes. It'll just take a moment for that to actually process. Then we can go back to our Pavilion documentation and you'll see that it's gone because it's updated. So we need to use the command update clipping drawings. And in this case, we're just going to say all because we're only going to update the one drawing, which is all of them in this view. And you'll see that it will update it with this background. The sensational thing about this is that if I go back to my model and change something and I want to update this section, I can type in the command update clipping drawings and either specify to update them all or just this single one, and it will do a live update of all of these drawings. The other thing that I'm going to show you how to do is create a drawing which is a combination between line work and an image. To do that, I'm just going to try to replicate the view that we've created in that section. I'm just going to go to my settings over here and change from perspective to parallel to get rid of the perspective warp. This will mean that we'll have roughly the same sort of view as we'd have in that perspective, which is quite flat. I'm also going to change the display to Arctic display mode like this for my image. If I wanted to, I could hide all of this green and blue line work through this layers menu, but it's okay for the time being. So I'm going to use the command view capture to clipboard, which again, this is just going to copy it onto my clipboard, which will mean that I can hit paste and paste it anywhere I want. So if I paste it here, then I can manipulate it and move it around, and I can make it so that it's in roughly the same position or exactly the same position as what my line work is. And again, like I showed you earlier, I could also go through and change the line work weightings under the layer options if I wanted to, just like I showed you earlier, but I'm not going to do it for the time being. I'm going to instead move it so that it sits properly on the drawing. So I'm going to unlock those layers, and then I'm going to hold it and drag it down here and scale it a little bit differently so that it sits better on the drawings. The final thing that I'm going to do is I'm going to show you how I can put an image here. I'm just going to drag this image onto the layout, and I'll import it as a picture, and then I can just place it on our layout like this, like a picture. And if I wanted to, I can move it around and scale it just like I did with the other drawings. And using these techniques, you can see how you can build up a really strong documentation set that updates dynamically just like Revit or ArchiCAD drawings do. So I hope you can use it for the documentation of really interesting projects in the future. And that's everything that I've got to cover today. So massive congratulations for those of you that have managed to get through this entire thing. I really hope that it's been worthwhile and that you feel like you've learned a lot in a succinct and relatively easy to understand way. Rhino can be quite intimidating, I totally get that, but try to implement it into your future projects and try to learn. It takes practice, and I promise you that once you start to practice it, you'll start to feel so much more confident with it. Make sure that you like and subscribe, and follow us on Insta as well if you wanted to learn from short form content. Best of luck using Rhino in the future. If you wanted to learn more from resources like this, check out the courses page on the website where there's heaps more courses and information. There'll hopefully be a lot more resources like this one there relatively soon. If you wanted to support more resources like this, go and look at all of the other sorts of things that we offer as well.